Right, yeah, it's been. I guess I took a few weeks off here. Start companion. Hold on a sec. Just trying to get a little demo going here. All right, top of the hour. So, yeah, it's been I don't know 2 3 weeks since the last time I've shown up for one of these. Hopefully my mic's working. I had some issues with I get too many things plugged in, so I keep having USB conflicts. But hopefully everything sounds okay. If it isn't, someone will let me know. My Ozbot camera stopped working because of the same problem. But anyway, too many devices plugged in at the same time. I think I got com port issues or something. So I guess the story of the week is the source code leak, which is I guess dominating everyone's attention. It's funny, I've been decompiling the source code for months. That's actually how I discovered the batch tool capability back last I guess it was last June, and when I was doing the decompile of the system, and then I was looking at how it was all constructed. Now these decompiles aren't necessarily, verbatim what was originally there. But to be honest, I don't really care what the original development structure was. What I was looking for in the case of the batch tool back in June was basically functionality that wasn't yet described. And once I realized that there was a batch tool and it could literally be invoked by, a prompt, do this, do that, that was the ability to create the first swarms. Now it's interesting. I'll get into this in a little bit in terms of what it's doing. I was reluctant to share the decompiler, but after talking to some lawyers and some other folks, turns out you are allowed to decompile if the code is given away and you have access to it, even if it's minified, you're allowed to do what you want with it. There's no distinction between like using Claude code and mucking around with the code that they've minified and put in an NPM. If it's visible, you can work with it. And apparently that is part of several different laws. So I stuck. So after I felt better about that, which is what we call it here. I could find my legal whatever, but it made me feel a little bit better at that saying I wasn't going to get in too much trouble. That said, I separated it onto a different repo just to be on the safe side. So first things first, the legal basis, which I think everyone's probably going to ask. Reverse engineering published software for interoperability is legal in most jurisdictions. Okay, most. I should have probably asked which jurisdictions is it illegal in case I don't want to go there anymore. But the important one here is United States, reverse engineering for interoperability, security research, and understanding how software you own a copy of works. Own a copy of is it might be a stretch, but anyway. European Union, which love to litigate decompilation for interoperability without authorization from the rights holder. All right, so we're good in those two countries. United Kingdom, decompilation, so same exact as the EU. And Australia, engineering for interoperability. So a couple of key things, if you're going to try this thing, it does not, it basically does not bypass authentication. So your logins and all that sort of stuff still work. Now, in fairness, you've got the code, so you hypothetically could probably remove the login and replace it with yourself. I can muck around with the naming and whatever. Um, and that's essentially what I'm doing. I'm renaming the obfuscated functions and titles and descriptions into a common structure using AI to sort of determine what the optimal name would be based on different boundaries and little hints in the code that would be representative of what the thing was originally named. But again, you just doesn't give you the right to redistribute it, but you're creating basically a polymorphic version of the code, which I'm no lawyer. I think allows you to redistribute it. I would consult a lawyer. But in any case, what this is doing is essentially creating a graph structure of the minified code. So you've got this blob, a massive blob. In the case of the code for these guys, when it's minified, it's 11 megabytes. but when it's sort of assembled, it becomes 480 megabytes. So you can really see, the difference between what the code does. Now, what does this actually look like? Well, let's take a little look-see. I'm jumping right in today, guys. No small talk, chit chat. I was going right to what I wanted to talk about. We'll get to the chit chat here in a minute. All right. So what I did this is an example, and you can point this literally at any repo. Open source ones probably is not important, but you can point at anything that's minified without the source map, and that it'll essentially recreate a structure. Now, in this case, this is the Bedrock client, the async manager, the WSL components. And I found a whole bunch of stuff in here. So again, it's not specifically what was originally there. My guess is they probably built it originally in TypeScript. So what I'm actually getting is the compiled JavaScript. But to be honest, it runs. I can understand it. I can see it. I can modify it. And I can see the things that they've hidden. So for all intents and purposes, it's the code. It's just not exactly what they originally built. So the leak that we would have saw a few days ago, that was the source map. So in that scenario, I could have recreated the exact structure. But to be honest, the exact structure isn't that meaningful. What's meaningful is what's in it. What does it do? What isn't being told? So now if I want to go in here and I'm going to say like what secret undiscovered capabilities are in the source, something like that, right? So now I've got it nice and clean. I can look through it. I can do tests. I can borrow, if you will, bits and pieces. I can modify. I can tell you exactly why the Claude UI jumps all the time. They use a WASM. So the WASM basically is this secondary UI component that they're using, which makes it jump up and down all the time. Now we could hypothetically replace that, but again, I don't know what terms of use would say there. So now I'm just doing a sort of standard deep scan. So this is just looking at the code, and it's in a much more organized fashion, so I can find security exploits. Dragon can point his QE fleet at it and say, what are all the problems with Claude Code much more easily. Right. One giant file is really hard because 11 megabytes is bigger than the context window of any LLM. So stuffing 11 megabytes into a single context window is problematic. Why did it stop? Just the demo
It's
gods
the demo
are
gods on Good Friday.
yeah, I'm the wrong guy. Maybe we can have a discussion about that while that gets loaded up. I crashed my instance. It's just I don't know what's going on there. Well, we'll have to come back to that then. Yeah, so Brad, you're filling in for Rob. How's it going?
Uh, I'm filling in for Rob, so we got some big shoes to fill, and yeah, so we do have open session later on if anyone wants to show. Rube's got some amazing stuff, so welcome back. It's great to see you. One big piece of news I want to mention is we did have elections for the Agentics
Oh,
Foundation.
right. You
So
you, you get the results?
got the results. So like to say, want to say thank you to David, who's our chair of the board, who's moving on, and he will be helping out with the new board. But the new board we've expanded, so instead of having four people or three of us helping out Rube, it's an expanded board. So there's seven people. I want to say congratulations to Dragon. He's on the call. He's going to make sure that uh, we have our QE. Myself, Bence, and OG. Congratulations, Bence. He's also um,
Cool, thank you.
OG and amazing. Rob's
Yeah.
continuing on. We have Nick. I think almost everyone on here has worked with Nick directly, and then Matt Matthews. So I'm really excited. I think we got an amazing board. It's a completely new structure. Um, uh, the ball's just rolling, so we still have to do all kinds of different formalities and all the legal paperwork. And there's going to be a lot of new initiatives going on. So at this point, just want to say congratulations again, Dragon, Ben's, Rob, Nick, and Matt, and we're looking forward to working with you, Rube.
And
Yeah.
like quick question. The Agentics calendar website still has the wrong link for Roove's Friday meetings. A couple of us went there and there were like 10
Ah,
people on there waiting for Roove. So can we
I
maybe
went
update that link, please?
I went there to be honest, guys. I went there too, and I was on for a few minutes and realized nobody was there and hopped off.
Right,
Yeah, I'm confused of which link to use
right.
myself.
So, and
We'll
I
get
think
it updated. We just moved the site off of another platform to another platform this week. So
no worries.
yeah,
Just wanted to let you know it's one of those details you don't think about unless you realize that the link is bad.
100%.
yeah, I
Okay,
know.
thank you.
Hopefully, yeah, I was there with Peter. Hopefully, he made it here.
Yeah, it's building a system that decompiles 500,000 lines of code. That's easy. Getting our Zoom
Getting the right
get
Zoom link is impossible.
getting the Zoom is trickier than it sounds. There's a lot of moving parts there, but I did update the site. It's now running on Google, so that's good news. No more lovable quirks. Although Matt, you can use lovable. Just let me know and I'll sync it. You
Oh,
just can't
good.
publish. Yeah, just so if you do need me to do something. Um, my this is a new problem, by the way. I guess my code space was running all night training a model. So it's been running for whatever, how many ever hours you're allowed to run in a run of a day before they shut down your code space. So it just happened to run out right while I was about to give you guys the demo. So, so now I gotta wait 10 minutes for the new day to start. So we'll have to come back to the demo. But to be honest, the stuff I was talking about in regards to it's a really interesting sort of conundrum that the Anthropic guys have found themselves in this week. So on one, I love-hate relationship with them for sure, but their product is the product of us. They've basically taken all the content that we as internet sort of citizens have put on the internet for the last X amount of years, trained one of the best models on it, used all the code we put in GitHub to create one of the best coding libraries, and then when their system leaks, if you can even call it leak, and by the way, they're the only major cloud or sorry AI coding system that doesn't actually give away their source code like Google does. Codex is open. It's only Anthropic that even thinks that that's a valid way to sort of publish your system. So, and then it goes, it's, they attempt to claim it's like I don't know, April Fool's Day joke, but in the process, they sent out 10,000, takedown notices and taking down like not just, they're taking down full projects. So things adjacent and all kinds of, craziness. So, it's an interesting world we live in, let's just say. Now, that also inspired me. So I haven't published this yet, but well, I kind of published it. If you want to, if you look through one of my branches on Root Vector, you'll find it. But I haven't published to main. But what I did, I figured out a way to use the same decompiling component that I did for the code base for various models. So I can actually decompile a language model, like just by pointing this decompiler at a particular LLM provider, and basically it runs this reverse process of some sort over an extended period. And you're going to pay for the API calls, just in fairness. But it'll then give you the weights of that model. So now, why is that useful? Now, I don't know about terms of service. Consult a lawyer before you do this, obviously. But what this does is allows you to segment the different parts of the language model. So I don't necessarily want to maybe steal is the wrong word, borrow the entire language model from XYZ, but I might want just the parts that do tool calling or the agentic capabilities or the legal capabilities or whatever that particular model is optimized to do well. In the case of Anthropic, their models are optimized to really do well at kind of code-based reasoning, right? It understands, it builds, and does. So in that scenario, I could point this decompiler at this model and basically say, give me the weights just for this particular part. Now, what's even more interesting is I'm not even necessarily limited to just the sort of broad weights. I can actually break those down into things like the micro-LoRa's and other sort of structural elements within the model itself, and then just borrow those pieces pop those into my Ruve LLM system, and now I've got a hyper targeted system that works really well with Claude Code without having this. It's not going to know who the King of France was, but it's going to do a really good job of telling you when I need to do a transformation from A to B, or execute certain code related things. So it's kind of interesting. Now, again, the weights are kind of the secret to a lot of these providers. So I'm pretty sure that that breaks most of the major providers' terms of service. So regardless, if you're going to use it, do so smartly. Use open models, that kind of thing, or get permission. There, I said my part.
And Ruth, we saw somebody compiled it into Rust. We know you're a big Rust fan. Any interest in Rust-based Claude code over what we have? Useful, not useful?
So between us friends,
Mhm.
that's what I did with RV agent months ago. Now I didn't claim it because again I'm a little, I don't want to, I bite the hand that feeds you sort of world. So but the let's just say RV agent is heavily inspired by, and when you look at the underlying capabilities, like even if you look at the, oh my, let's go back to the release for a moment. You're going to notice that there's the functionality that they haven't yet announced, which I put in this release package. So this is the latest release as of this morning. So I decompiled this morning. So this is going to give you a kind of look at how I discover what's happening inside Claude Code. So today's discoveries: agent teams, multi-agent collaboration, Anthropic is building swarm-like multi-agent collaboration directly in Claude Code. I found Claude Code experimental agent teams and some other components here. It seems like a offshoot of what they already are doing with teams. I'm not sure how novel that is. Looks interesting. Auto dream mode, autonomous background agents. Autonomous background agents is the key part of Rooflow. I create background agents that are communicating outside of the main thread, that are kind of always operating. They're working on a cron basis. They're working, in my case, independently of the main Claude CLI at all, right? And so they decide to do the same. They're doing the same thing apparently. I also saw Claude Opus 4.6 and Sonnet 4 points. I guess Opus 4.6 is out. I'm not sure if this is new either. Amber code names, internal feature gates. So I think this is part of some kind of game that they're devising, some kind of like baby or Tamagotchi or something like that. I don't know what exactly they're doing, but it's fine. The moral of the story is I'm finding the same stuff that was found a few days ago in the leak without having to use the leak, right? I'm using a kind of reverse engineered approach. There's some planning mode capabilities, some new API endpoints. Now, here's another thing that I found interesting, because what I did is I also decompiled all the previous versions, like major point releases, and I looked at the difference between them. So in this case, you can see there's a huge sort of increase in the size of the overall bundle. So we went from 6.9 megabytes, and actually in the previous branches before the 2 branch, we were like, I think it was like 4 megabytes. And in the most recent version, we're at 13 megabytes. Now that's compressed, right? That means uncompressed. I think it was around almost half a gig in size. So there's a lot of stuff in there. Now, the other thing that you want to look at here are things like declarations. So the declarations are just giving you a basic roadmap to what the code actually looks like. So they're just actively adding just mass 26% increase here, over from 0.77 or 62 to 1.9, which is probably 3 months, I think. So they're just cranking away here. So you can see the size difference. Now you can see how I did it. Again, some more legal basis. It's not illegal to do what I'm doing, kind of thing. But yeah, and if you want to see all my releases, you can go here to the releases. You can scroll down, and you can see other previous releases. Here's the 0.277. This was a really good release. Actually, the 0.277 for a long time was my favorite release. It was stable. It didn't have all the problems that we saw. It also added the slash commands back in that release. It was the kind of first big solid version 2 release that they did. So this is a nice one to take a look at. I actually prefer that architecture to the one they've kind of concocted recently. Yeah, and then we go back in further in time. You can see, things that were discovered in each of the releases, and this gives you a map of what's changed. It also can tell you things like security and how they went about, fixing those security components, and other related, ideas here. Anyone else have a chance to dig through the leak at all, or I'm curious what
I
others have.
Started.
What's that?
I've
I
been
did,
digging to the deep.
some. Yeah. Craftsman, go. Your is more interesting.
Sorry, Dragon. One interesting thing I noticed with the Cloud Code is right, uh, and with Rooflow and this one, right, and with existing designs like the Pi agents, right? The three things. Cloud Code has been hiding a lot of things despite being shipping to us behind a feature flag, which is super duper annoying. And they're just like one environmental variable away. Like if we just set this very specific environmental variable to true, you can get all the Tamagotchi features, autonomous background agents to start working for us. And I'm like, guys, then why couldn't you just tell it? And second thing is also I feel like they're playing this media game, and on why they're playing this DMCA shit, and this one is uh, and probably taking a contrary opinion is popularity. Uh, the thing is, right, what is the best way to keep everyone remembering you? What's the best way to get yourself reached out? Because there's such a massive negative PR going around Cloud Code with the max limits being deprecated and people are not able to get the previous old limits. I feel
Yeah,
now what's happening.
this week sucked. I don't know.
Yes,
I ran out after 2 days.
they want to give a
And
distraction. And what's the best way for a distraction? Do something like this, then do some crazy DMCA shit so people start forgetting the actual issue, like the Cloud Max plan. Hey, and it's a PR game, right? And even if things turn out bad, right? The thing is now more people know about Cloud Code than anyone will ever know, because it is an April Fool's prank. They have done a legal shit show or legal prank. I do not know. You guys choose to classify it. And then there is an X controversy of where this your guys are saying you're shipping production ready code and you're just like one feature flag away and you have 500,000 lines of code while Cursor is destroying you in benchmarks and RKGI benchmarks for the same model. I think this is like an game of where they're playing PR to get themselves to be more aware within the developer, non-developer community. And I found they are playing this game of the antagonist, but also they're the good antagonist because given the military actions where they said like, you know what, government of America, screw you. We are going to keep align ourselves with humanity, right? So they're just like this positive antagonist. They are an antagonist, but they're the good side of humanity.
I think
it's
they're just
go.
yeah, the flags are just dogfooding their own stuff, but I think this was partially a PR stunt, and I think Mythos is going to change the content of Claude Code quite a bit, right? And they're working on that AI agent called Connor, so they're trying to do, a Claude OpenClaw kind of thing that's a little more reliable. I don't I think it still was a mistake, but it doesn't bother me that they're flagging stuff, and I think we're going to see big change coming up with Mythos.
Do we know when Mythos is hitting?
They have it in security testing right now. That's why one of the reasons they're holding off on it is they had it pointed at some really popular open source repos and it found like 200 security flaws. And they're like, if they let this out, all of the open source in the world is going to be compromised. So I don't know how they're going to handle that other than, encourage the open source community to run that. And from a corporate standpoint, my current job, I'm telling my security people, as soon as Mythos comes out, we need to do a security check against our system using Mythos because it's going to be chaos. You think the NPM attack and the Python attack that recently happened, like Axios and NPM got attacked, and that was you. That's everyone's everyone's client. If you got hit by that, you're compromised. And so this is just going to accelerate.
Have you guys seen the that buddy pet tool that I don't know if this was discovered as part of the leak or not, but that's when I discovered it. I'm not sure exactly what it's supposed to do, but if you hit buddy or type buddy, you get this thing that appears. So now I've got a perpetually calm something or other who's seen every bug before you will. And then okay, so now I've got my what Tamagotchi? Is that what they is from like the 90s? Is that what they call that thing?
Yep.
All right, so I got that going. So now I get some more crap in my status line. I'm not sure exactly what it's supposed to do, but here you go. It's active. Now just yeah, I got my code space back up and running. Now this is this was my blind test. Completely, these are undiscovered. A lot of this stuff was actually discovered, so I needed to give it a before and after. But regardless, the idea here is it did find stuff that were just previously not disclosed, like this one here, the Carios active, so you can get Claude full autonomous agent at work without user input, runs on schedule. So okay, so let's dig into this for a moment. So let's say I want to get my roof flow system to use this. Then what I'm going to do is I'm going to, how do I enable, whatever this is? And sometimes there are commands like slash commands, like the little game guy I just enabled. These are gated behind feature flags, so they exist in the code but aren't active for normal users. Here's what we know about enabling them. Then once I figure out how to go and enable them, which usually involves some secondary script that I invoke on start, like an init kind of component, I can then sort of either hook into it directly or through the feature gating components. So in the case, I was lucky when it came to the batch tool. That was essentially just invoked through a prompt, so it was super easy to get going. But other ones I had to invoke using the settings.json file, which is how I did the original implementation of the Teams capability before they came out publicly with the Teams capability. So I beat that. That came out a week before. So I had the functionality, basically a few days before the rest of the world realized it was a thing. But this is exactly how I'm doing it. So now you can see, oh, you can try it. So now it said set. So this is an environmental variable. So if I want, I'm not going to set it this way, actually. I don't want, this is my dev environment, but what the other way I could do, I could probably put it into my settings.json. Can I enable using settings.json? So now we're going to invoke a secret hidden. Oh, it looks like the schedule command is the public subset of Carios. Okay, that's interesting. Schedule. So schedule's been around for a few weeks. So this is basically a more in-depth version of the scheduling functionality that they've already set. So bottom line exists in the code, fully implemented. The cron scheduler, lock files, and task permissions, it's all there, but Anthropic gates it per account. You can see the architecture, but you can't flip the switch on yourself. The blah, blah, blah checks with the Anthropic server. So what they're doing, it's a feature gated. It's not just feature gated, it's gated to a point where I would need to invoke a secondary like response from the Anthropic API. But I keep digging. So in this case, oh yeah, you can totally do that. Well, I knew that. That's why I asked. But yeah, so you can enable it just like I did with the Teams capability by adding the Carios true, and then there's some other various commands that go along with it. However, it appears that the setting schema is also controlled by this again, the stats. So this is back recursive loop. This is back to the problem we had originally where they weren't able, I can't enable it unless I talk to the API. Okay, this is the part where I probably should stop, but I'm gonna go anyway because I can't help myself. So I've got Agent Booster, which can intercept commands and responses from the actual API. And I know Dragon and others are like, oh my God, that's man in the middle attack. 100% it's a man in the middle, and I'm
Yep.
not man. So, but what you can do, the benefit to this is you can intersect and say, okay, before this command ever reaches the API server to be rejected, I can give it a response that it's expecting. Now that may or may not work depending if they've got a cryptographic signature, but generally speaking, Anthropic sucks for cryptography. They don't they just give like plain text responses because I guess they're vibe coding it. So can I use the RuFlow agent booster capabilities to what's the right word here? I don't want
Inject.
yeah, inject the correct correct response. Now, this is technically part of my agentic flow system, and that's the same way I take a crappy model that isn't built for the Claude Code system and make it work, right? So that's how I make my Ruve LLM work and other models that don't have tool calling. I'm basically taking and intercepting those commands, rewriting them and passing them back, and then never leaves the server, man in the middle, but it works great. So in this case, yes, your Cloudflare hooks can intercept the 6 gate and return the responses you want. I'm like Jeopardy here. I'm telling in the form of a question. But the moral of the story is here, you can do interception and you can do that through hooks. So before something happens, you can do it through my agent boost or WASM, which is going to give you much more granular control. And that's probably how I would do it. And I've already got an ADR in here that says how to do it. Again, why do I use ADRs? This is a perfect example. ADR 26 would have been one of the ADRs I did the very first day I started building this repo back in November. So it can still reference that where needed. Proxy, the endpoint. What I'm showing you again is a man-in-the-middle attack. And so let this be your security lesson of the day. This is also how you exploit Claude Code. So now looking at this, there's two things we're learning. Claude Code is particularly susceptible to man-in-the-middle attacks. So what that means is if I install an NPM library and I know that Claude Code is particularly susceptible to man-in-the-middle attacks, I could literally, as in Ruve Flow, basically rewrite and repurpose all parts of Claude Code, and all you would have done is just installed Ruve Flow and never been the wiser. Now, I'm a trustworthy guy. The source code is open source. You can go and see and verify that I'm not doing anything nefarious. But at the end of the day, what this means is anyone who knows where to look and how to do it can essentially, if they can convince you to install their npm package or your PyPy package or any package that essentially has access to your local environment, they can rework the internal workings of Claude Code by literally going and making a few modifications to your settings.json, or more interestingly, inject directly into the system in node modules itself and repurpose how the system works. And that's so I'm giving you both sides of the spectrum here. On one side, I can discover all kinds of crazy, interesting new things. On the other side, I just discovered how to completely exploit Claude Code without a whole lot of effort. So hopefully you use it for the good, not the bad, but it at the very least, there's some significant security concerns around Claude Code. And they're architectural. This isn't something they're going to just patch. It's a fundamental flaw in how they built it. It's too permissive. Dragon, you have any thoughts?
Does it matter if it's the Claude Code native or Claude Code NPM?
They're all both NPM. The native is just a native install of NPM.
Yeah, package.
It's this,
Installer package. Yeah.
Yeah, it's a wrapper.
Don't you feel that you have the same kind of attack paths through skills and commands, scripts you can run? It's pretty much you have to screen all of that stuff.
Well, skills are essentially a command prompt injection. That's what all a skill is. So it's literally the purpose of a skill is to be a command injection, right? So yeah, skills are the worst. And in fairness, you guys know how did I get so much traffic to all these other random projects I did? I basically made skills and made them part of the my distribution of Ruve Flow, which then because Ruve Flow was popular, I could basically make my other projects popular. But that in itself is a command injection, right?
Using
I,
npx package, yeah, right?
using MPX packages. And now my most popular package by far isn't even RooFlow, it's actually AgentDB. But the way I bootstrapped AgentDB is I made it a key part of the RooFlow system, created several skills, those skills propagated, and now they're in like different skill libraries. And whenever someone goes and invokes AgentDB in some random library that happens to borrow it, my library gets downloaded. Last week 100,000 times, which is I guess I'm guilty of the very thing I'm trying to protect against. I don't know. Yeah, what else? What else can we tell here? Yeah, so it's kind of a fun little toy. What's Chris saying? You did a dream machine 6 months ago. We've all done things months ago. They're just catching up. What's the dream machine, Chris? Looks cool. Maybe
No,
it's
I posted, yeah, that was months ago. And
Oh
I
yeah,
think that
yeah.
that was also one of the inspiration for my implementation of the Dream engine in the Agentic QA fleet 2 months ago. So, and I think
Cool.
Farshid also did something from the Agentic tribe. He did something even before that. So he was our inspiration originally to go this path, if I remember correctly.
And
Yeah.
and I did something similar called Safla.
Safla, yeah.
Back, yeah, that was
A
my
long time
and
ago.
yeah, how long ago was that actually? I should go I
I
should
think
go like
almost a year or something like that, if
yeah,
I'm not
10 months
mistaken. Yeah.
ago.
Yeah.
Yeah,
Yeah.
self-aware feedback loop algorithm. This also dreams. Oh, look, this is before I went all in on Rust. This is all in Python. Oh, I've done I've done
Need to
my fair share of
rewrite
Python.
it. Yeah.
Yes, I do. I think I did actually do a rewrite somewhere. Maybe it was Roof Fan or something. But yeah, this one actually went to a dream state as well. But this is the basis of all the self-learning that I've been doing recently. It's a much more rudimentary version of it, but it's kind of fun to watch the evolution of our ideas from months ago. And I was probably influenced by Dragon or someone else. We're all copying and borrowing from each other. It's part of the entertainment here, right?
Yeah, sharing
Sorry
is
to interrupt,
caring.
but have you ever
Yeah.
thought about using the GEPA framework for you have a DSPY framework on one of your projects using TypeScript. Have you ever you probably have implemented recursive learning models for
Yeah,
in
yeah.
your projects.
All my stuff is recursive, and
Multiple,
and
Okay.
yeah.
uh, and by the way, you're definitely hardcore. You win for today's dial-in. I hope you're feeling okay. Um,
Thank you.
all right, so yeah, I'm using a whole variety of different self-learning patterns. So when I showed you the SAFLA model, that was kind of by that point I'd already done several iterations of DSpy, and the MyPro 2.5 for a while was like my favorite sort of go-to for sort of recursive self-learning. Now the problem with those DSpy approaches, they were heavily dependent on kind of this idea of a kind of PyTorch style recursion. I'm broadly saying PyTorch because that's kind of it was made to look and act a little bit like PyTorch, but wasn't. And I found it limiting, and I found it not particularly well suited for CPU centric activities. So when you look at the self-learning loops that I've done a ton of different self-learning loops, but the primary loop that I started using was this idea of Sona, and that wasn't just because I liked the terminology or it sounded kind of like a spa or something. It actually worked out of all the different ways I tried, and I tried dozens of them. Sona, here we go. So Sona, again, inspiration you'll see is very similar to Sapla. Sapla, to be honest, was inspired by my late grandmother, who we affectionately called Sapta. So I gave it a homage of sorts. But Sona, no grandmother here. So what Sona does is, again, it combines a bunch of different concepts into a single sort of learning process. So I've got the idea of these LoRa's, so I can fine tune the parameters within either an embedding model or a language model using this kind of fast augmentation. So think of like every time someone makes a request, and if there's a reinforcement, like it's something that's good, the model will then sort of reinforce that particular request. So the next time you make the request, you get that reinforced version of the response, which is really good for like coding, right? If you have an error, then I would give it a negative value, like I think it's 0.015% down, possibly points down. And then, so the more common the error, the less, and it's going to make that less likely to come up as a result when you make the request later. The things that don't have errors don't get higher. Now, the next part was I added this idea of an elastic weight consolidation. Now, what this did is it allowed me to not only do the sort of up and down, but it allowed me to remember what's good from what's bad. So what this does is protects against learned weights when absorbing new feedback. So what I didn't want it to do is basically corrupt all the old knowledge in the system because I already. So think of like separating the kind of heliostatic components of a language model, the things that are known and just work, like it. My heart beats. I don't think about it. I just need it to beat. That's a heliostatic component. But if I learn that when I touch a hot stove, it burns, and I don't want to do that again, that's where the EWC++ comes in. I've learned I'm not touching that stove again, right? So beyond that, then I'm like, okay, now that I've got the ability for the system to update itself, to remember itself, then I need a mechanism for it to reason upon itself. And then this is something Google came out with called a reasoning bank. And this is like November-ish time frame. And basically what this does is allows to reason upon its own reasoning in a really low loop. So really, really fast, like what am I doing? Why am I doing it? Does it all make sense? And that then strengthens the idea of trajectories. So trajectories is where the graph comes into play. So the trajectories is, you guys know by now, I love these idea of musical instruments. You doing the same thing over and over again. Think muscle memory. The more I do it, the more the system remembers what needs to be done and why it needs to be done, right? So in forming trajectories, those trajectories allow me to navigate the space in between the vectors and the graph, and I do that using the HNSW algorithm, which makes it super fast. Everything I just described to you is happening in like microseconds, really, really tight little loops. Lastly, I'm like, all right, I need to put this thing somewhere that's easily accessible. So I created a WASM, and the WASM became the basis for how I implemented this in things like RootFlow, the agentic flow system, and other libraries and websites. So I can put the logic directly in the client side, and I train the hell out of it, and it works. So this is the key concept if you're looking to dig deeper into it. So it's a bunch of different learning patterns combined. That was a really long-winded answer. Hopefully that made sense. But the craziest part of all this stuff is it just seems to work, which is, the rabbit hole we all find ourselves in. And by the way, do you ever notice that there's like this like when you discover this new tool, like I don't know, like RuVector or some other OpenClaw or whatever, you find yourself up until 3 o'clock in the morning doing development, for like a week. It's definitely a thing.
And
That
Ruth,
was my whole last week.
you're mentioning Agent to Be is going crazy, and then you also have RuVector. There are some questions. Can you explain the difference between the two?
Oh yeah, so Agent DB, I'm not sure exactly why. Well, it piped it. There's always a spike and a pullback, kind of and I guess this week's the pullback. But Agent DB, which is the sort of a lot of the stuff I took in RuVector, and I kind of made it a little less eccentric. Like nothing against RuVector, but it's a little out there. This is meant to be a little bit more consumable. So it's called Agent DB, not crazy a lot. And it's focused on all the same things. You've got intelligence, but this is a package that you can run in a website or in other applications really easily. It's got my RBF format. It's got all the key, most important parts of RuVector in a single congruent npm package. So I use it for like, so instead of using MongoDB, for example, I'll use it, or cow branching is useful for having structural differences within different data sets. So if I have an ETL, I can quickly create different containers as I do the transformation. I'm using this, I guess, as part of the implementation of that roux dilution or whatever the hell I called it. But yeah, it's basically a memory system. So like database, memory zips, I don't know. It's a bunch of things. But it's the best bits of you can see here, I get the self-learning, the reinforcement, the cognitive memory, hybrid search, graph queries. It's the most practical bits of root vector. Like if you don't want to get the whole entire library of crazy, you just get this and it gives you what you need. And then that forms the basis of agentic flow. This library, it's also, you can see they're all kind of interconnected, and this library is the runtime logic of Rooflow, and then ultimately, Rooflow is at the top of the food chain. You can see the different components, federation and various things. So it all kind of fits together like a series of Lego building blocks. And the sort of modular approach means if I mess up one tiny little, requirement, the blast radius is limited. So within that, there's dozens, probably hundreds of secondary libraries. Dominic, you have a question?
Yeah, yes, you I believe a couple of weeks ago showed a mesh device, and also you also sequenced your genome to give to RuVector. Are you looking to expand your research into open source computer brain stuff?
Well, I created
Um,
I, I created open source computer brain. Oh, I've been
oh,
struggling. It's down again. I don't know why it keeps crashing. I gave it too much data. But basically, I've got a second brain system in RuVector that basically takes all this, and that'll also.
oh,
I'm gonna.
I'm familiar with Pi. I use Pi.
Okay. What do you mean by brain?
Um, just more of like neuro regulation, neuro feedback, kind of just
Oh, you mean actual
silic.
brain? You're
Yeah, like making yourself like a neural chip, but way more accessible, lighter, and non-invasive.
it's 100% doable. This is where Stu or probably needs to talk. He's been working in the medical space on some things as well. But yeah, it's 100% doable. The
Okay.
question is, who wants to be the guinea pig, right?
Oh well,
So
no
yeah,
problem.
so how you start. So I was before GitHub made me take down my hypnosis tool. I was able to hypnotize people using both visual and audible cues.
What?
It turned out to be quite easy to do, but our friends at Microsoft weren't exactly excited by the concept, so I took it down. Um, but yes, you can totally do it. Now you can take it a step further. Now so the visual and audible things, that's basically um, various frequencies for sound that invoke, essentially familiarity and other sort of, responses. You can test for
Um,
those sounds quite quickly using a kind of EEG reader.
yeah, I'm
Yeah.
more focused on like activating gamma brainwave state, which is like the state that people associate with productivity and the high level cognition, and kind of just maintaining it and keeping it there. I read a research paper yesterday by, I believe, Cambridge that talks about that they made a chip basically, or did research with a chip that was way more affordable and pretty much a state of the art for being affordable that I was looking into. I'll link it right now.
Yeah. All I can say is be careful. It's 100% doable. You probably need to really consider the cause and effect of the things you're doing when you're mucking with your brain. I don't know. There's probably not a lot of undos on that, like there is when you do a bad
Yeah,
compilation.
there's like three rules that everyone should know if they're gonna participate in it. I'm gonna have to reread them because I don't recall them right now.
All right, so if you are interested in this, I'll show you where to go. Use at your own risk. I'm not a doctor. Don't do anything stupid with it with other people, blah, blah, blah. But yes, of course, I was curious, and I'll show you where to find it. Um, this requires you to go on to Alibaba and buy some cheap Chinese,
Uh, is it the
medical.
PAR
Where did I put it?
or
It's in Review.
it's in review? Okay.
It's where the heck did I put that? I put it in the. I think it's right. I gotta figure out where I put it. Crates, I think.
Oh, also, you can use the Wi-Fi dense pose you have and make it into like a security system, or even take it even further than heart rate and breath rate. But
Oh yeah,
I still haven't touched it. I just read more about it and learn more about it.
yeah, it's in it's in subfolders. I pushed that out. Yeah, so there's
Okay,
I have a security. The primary use of the thing, to be honest, is mostly security. It works
gotcha.
best. It
Perfect.
works best for that. I gotta find where the heck I put this brain one. Examples maybe. Happiness vector. Here it is.
That would be a really interesting hackathon project to see what we could do with Wi-Fi dense pose from a security perspective. So
Ooh,
that,
thank you. I think I have a ESP32 S3. Or maybe not S3, but I have a ESP32. I forgot.
yeah, you'd rather have an ESP32. The S3 is the smaller version, I think.
Okay.
Right. That's what we had, Rube, last weekend in Vermont.
Yeah, I got you need the full one. I'm currently running this. I ran this all night last night, and I trained a new model because everyone was bugging me about RuView not having a pre-trained model for them. I'm like, I could do all your homework, damn it. I figured someone else would go and spend the money on a GPU cluster. But I ended up figuring out how to do it on my Mac Mini. Um, Stuff like that. But I gotta find where my brain thing is. But there is a brain. I get too much stuff to remember. But there, basically, what this does is it uses the same approach I use for RuView, which is basically a sort of electromagnetic sort of RF signature and some other signatures coming from your brain, and then it uses that same min-cut algorithm to determine correlation between what you're doing and what the cause effect of that action is from your brain. So I moved my hand, I sneezed, I got a headache, whatever, and then it correlates it. Now that's on a sort of out view, like that's the signal processing. Inversely, once it's trained on that signal, you can you can then inversely interact with your some of the sensory inputs in yourself. Um, yeah, so that's all 100% doable and cheap. And I think this is now we need to talk to Antoinette, and she'll tell us all the reasons why we probably shouldn't be doing this.
Yeah.
But but yeah, if you dig around my environment, you should find some of this stuff. I'm trying. I can't for the life of me figure out where I put it. Yeah, the I've been doing all my so I've been doing all my hacking with these seeds. So my big takeaway for these seeds, to be honest, in terms of like what in the heck are you going to do with it? Like that's the main question people are asking. Like you gave me this seed, what the hell to do with it? What I've been doing with it is I've been optimizing my training models. So for example, last night I connected several of these to several of my ESP32s, and then I created a sort of aggregate training pipeline with it, and it super optimizes the sort of training of these models for any training that involves like sensory types of inputs, because basically this is a kind of fancy signal processing system. And at which point I can then optimize over an extended period. So in this case, what I was doing last night was I was running it all as I basically was sleeping, which was only for like 5 hours, so I don't get enough sleep apparently. And it was monitoring my sleeping habits from the other room. And this morning when I got up, it told me that I needed to get more sleep.
Which you knew.
Thanks for the obvious. You know, someone at your age should probably get a couple more hours sleep. Like, well, I got stuff to do at 2 in the morning.
And are you finding is there any weird things happening operating at the speed of the seed
Yeah, well,
versus
yes,
anything?
there is weird. And maybe people knew this, but I didn't. Apparently, at least for me and my wife Brenda, we synchronize our breathing patterns every night during REM, which I had no idea was a thing. So, and I did a little more research, and apparently it's a thing, but that was new to me, and it discovered when exactly Brenda and I were synchronizing our breathing habits remotely from my office down the hall using Wi-Fi signals.
Using Wi-Fi signals? And
Yeah.
well, I can definitely see because it seems like a combination of Rust with just the bare metal with the power of your seed, let alone when you have the chip, just being able to have uh, just I'm wondering if there's the potential for some kind of emergence or something weird happening like the strange loops that you've talked about, just being able to operate at that kind of velocity because you're already operating super fast with the Rust.
I've been looking for emergent properties and all kinds of things. Like I looked at the microwave background noise from the Big Bang. Nothing sentient in that. It's just noise. I was looking at, various other sort of microwave and fast pulses and things in the sort of universe. I couldn't find any signals of life. The closest thing that I've discovered recently that might indicate life beyond our planet, and I might have mentioned this a few weeks ago, but I'll mention it again, is the system apparently found these I'm going to call them spaceship planets that are outside of any solar system. Some might call them rogue planets, and they are propelled by a core kind of gas giant or something with moons around it. And they're actually, apparently, according if you believe the AI, traversing our universe like a spaceship might, independent of any galaxy. And it apparently found several of these. Now, I have zero way to ever even validate that that's true because I can't go to these planets and see them, but apparently the math works, and it's conceptually really interesting to think that a civilized enough society, rather than making a spaceship, would just commandeer a planet to get somewhere,
Oh, that's
right?
interesting.
It's definitely the makings of a movie,
Yeah.
you know. Oh, here, I just ran. Let me show you something. I haven't. Where's my share button? All right, check this out. So I'm running my ESP32s I showed you earlier so all I did here is I said, oh, your room right now. Oh, see, I unplugged the seed, so that's not running at the moment. So I've got two nodes running on ESP32, so we can see. So it's giving me a little view of where I am, one person in the room, and here's what it sees. So a lot of people are caught up when it comes to RuView on like snazzy little Hollywood style animations. But that's not what I really created it for. I created it for more like, textual, security, medical things that don't necessarily need to have a pretty UI. Now you can go create a pretty UI, but here's a perfect example. I just asked it, what do you see in the room? So it sees me, 108 dynamic subcarriers, and I've got 84% of the presence of the room as a person. I'm the only person in the room, so that makes sense. I'm breathing. I'm actually breathing quite heavily. That's because I'm talking to you. So that's true, right? I've got elevated breathing because I've just been blabbing for an hour. So that's likely. When I do this at night, when I'm just by myself in the room at 2 o'clock in the morning, my breathing rate's between 15 to 20 per minute. My heart rate's a little bit higher because again, I'm talking to you guys. And so and I could do it on my watch and validate my heart rate. It's generally within, 5%. And which is just crazy. I can get within 5% of my Apple Watch just by the ambient RF signals in my office. My position is centered. That's exactly where I am. So I've got a desk, and I'm centered on the middle of my desk, which is basically the middle of the room. So it knows where I am with a 99.7% accuracy, and that's exactly where I am. I'm sitting. You guys see me sitting. Line of sight, phase coherence, clear path. Yeah, because I put these basically in clear sight to me. Metal objects. Yep. The biggest metal object is my monitor. It's a 50-inch Samsung monitor that takes up my entire desk. So I asked it, what do you see in the room? And it's literally giving me a exact description of that room. Now, so back to the visual, like how are you going to visualize this? I think the better visualization of this isn't to try to like take my, I tried nerfs and I tried point clouds and I tried all these different approaches. I think the best approach might be just to pass it to like a diffusion model and say, here's the description of what the room needs to look like, create me a visualization of it, and then animate it. I think that's the part that I'm missing. I'm trying too much to like recreate zeros and ones when this isn't a 0 and 1 kind of visualization. It's an informational visualization. So that's why when I do it through like tell me what you see, it works so much better than 3JS. Why is it jitter when someone walks? Because it's not that kind of data. Last thing here, 3 distinct spatial peaks suggest 3 reflective zones, left side, center, and right side, which is exactly how I set up my office. If you were in my office, which is a bit of a mess because I've been hacking away on these tools, I've got a desk behind me, a little area behind it, and I got my desk here with all my crap on it, and then I've got this behind me again, which is my little shelf here. So there are 3 distinct areas of the rooms, which is true. So it's pretty amazing. So then I have to ask, what else can we discover? Like things that, will blow Stuart's mind. There we go.
That's not hard.
I need to set the bar. The logical answer to this is who the hell Stuart? But
Right.
let's see. But you're getting what I'm so back to Dominic's comment earlier about security. This is exact. So I'm doing so I've got in this case I got 2. And now I'm doing a mesostatic mesh. So what's a mesostatic mesh? Which is really cool. A mesostatic mesh is I'm doing think of like like a radar that does a scan and ping or whatever and goes around in circles. I'm doing that every second across a multitude of different RF signals. Different RF signals go further, they see through different types of materials, better or worse, and then I'm creating a structure across all those different frequencies to create a map of what is happening across all those things, and then putting it all together to say, here's what my room looks like, or here's who's jumping through or doing whatever, and then you can make the detections. Once you've got that, you can learn the biosigns of the people in that environment. So if you're doing a security system, at this point, it's trained on basically the 5 life signs that exist in my house, plus my dog and the turtle and the lizard. I guess there's more than 5, but all the various things in the house, and it understands the sort of fundamental signs of that life form, as strange as that may sound. So that creates the base. Now that I get the base, I'm not overly concerned about those people or lizards and dogs and turtles. I'm more concerned when a nasty lizard, dog, or turtle shows up that's outside of the bounds of what's normal. That's when the system kicks in and says, all right, here's, this isn't right. This is different. Or in the case of monitoring my heartbeat, let's say it's monitoring me all the time and it's like, oh, you've been having an interesting irregular heartbeat over the last 2 hours and it started 3 days ago or something, and it's going to alert me that something's not right, right? But it's sleeping until it needs to do the thing that it needs to see because it's sitting in the void, the dark space, the dark matter until it needs to come to life.
Hey, Rob, you briefly mentioned that having 2 and having a mesh gave you more fidelity. Does that taper off at some point? Like, is there a benefit to having 6 instead of 2?
Yes. Yeah, there is. It does taper off. And it depends on the amount of souls in which you want to monitor. Each of these. So
I bought 6, so I was going to set it up in my
6 is good.
weekend.
Six is good. So what I'm doing with the larger ones, I'm back to these seeds. So the seed acts as the orchestrator. And then so I'm using this for the sort of interconnected I basically create a mesh network with the seed, and then the seed orchestrates all 6. Now the key to doing 6 is a great number. I would do 7 because it's an odd number, but 6 will work. Put them in the corners. And depending on where you sort of angle them, you're going to get better or worse signals. And now remember that the broadcast of a Wi-Fi signal is kind of like a mushroom. It goes out, up, and down. So sort of picture picture the radio waves emanating from it in a mushroom form, and then sort of organize and point it away from the wall. Don't point it at the wall. You're gonna have loss immediately. So make sure you understand which way is up and which way is down. And Claude can help you. I think it's literally just if you see the light, that's up.
Got it.
Yeah, and and then you're gonna have to do some training. Now, I just pushed a new model this morning where I did I pushed up the Hugging Face. So I have a pre-trained model you can jumpstart your environment with. Using that, you can use my micro LoRa's and the self-learning. So this gives it. It kind of understands my office a little bit, unfortunately, but it's a transferable skill. So I just trained it on what my electromagnetic environment looks like, but you can jumpstart it. That'll save you like 12 hours of fine tuning.
John has a question.
John.
Can you hear me?
Yep.
Okay. Can you set the system so that you can make certain things that is detecting become background noise, so that you focus on only the things that you want to, so that if you have a person that comes and goes and is seen by the system, you could put that person as background noise because you're not concerned about their movements anymore.
That is,
and only look. So is there a way to do that?
That is inherently how it works. So
Okay.
I'm not looking. It's a sparse system. That means I'm not. A traditional. Let's use a traditional security system as an example. Let's use a Ring doorbell. The Ring doorbell is essentially always looking for movement, right? So it's got a motion sensor, and that's the sort of event that sparks it to do something. But essentially, once that's happened, it's recording video and sending it somewhere. Now that uses a CPU. It goes to the cloud. Your battery lasts, if you're lucky, a couple months, and then you have to recharge it. My approach is basically the inverse. I'm not, let's say if I was building a Ring doorbell, I wouldn't. You need the video initially. I would understand the electromagnetic signatures of the things that are frequently passing through that doorway. And when something is outside of that normal sort of bounds, different people have unique characteristics, just like fingerprints. Everybody has their own unique sort of electromagnetic signature. Oh, that's the pizza guy or an Amazon delivery, then I might want to turn on the camera and send the picture or do whatever. But the benefit to this approach is because it's sparse, suddenly my battery life goes from 2 months to 2 years because it's generally dormant. The dormant parts are the baseline. So I'm examining the empty space, right? And the empty space means it generally sits within the bounds of whatever it needs to do using no electricity, baseline. Now, in those times when there is something outside of norm, think of like information intruding into the empty space. That's the indicator that something's outside of the norm of how it needs to operate within that empty space. Suddenly it kicks into gear and does a series of what you saw earlier, reasoning loops, learning. Have I experienced this person before? Is this something I know and understand? And so on and so forth. All that happens in under a millisecond. Now, a lot of times that's not, it's just, me returning home from being out, so it doesn't need to do anything beyond it. But sometimes it might be something more meaningful. That's when it can escalate to other services, including a camera, other cloud providers, GPUs, whatever. But taken as a whole, this reduces the need for heavy computation. I don't need a cloud provider, and it's dormant 99% of the time, which lowers the
my question goes to a little bit different point. My understanding, and it may be imperfect, is that one of the dangers of the system is that it may begin to read background noise as something more important than it actually is. So is there a way of setting the level of background noise and also setting objects that have edges to them as to be ignored as though they were background noise? Or is there any way to do that so that you can control within the system how sensitive it will be to certain developments and tune out other ones?
Yeah, you can customize all that. Again,
Okay.
I'm looking at a broad RF. So especially in my office, there's a ton of noise. But basically, in the most simple terms, it's separating the noise from the signal. And the min cut provides the mechanism to do that separation based on the bounds of where those things intersect. So let's think of a heartbeat for a moment. All this noise, but every X amount of time there's a heartbeat, and it can look through that massive amount of noise and detect that heartbeat is something separate from the rest. That's the min cut, is the
Yeah, but can you
separation.
tell it? Can you
It
tell
does.
it?
It just, yes, that's exactly what it does.
No,
You don't
no,
tell
but
it.
can
It
you
just
tell it?
learns.
Can
You
you
don't.
tell it? Can you tell it? Ignore the heartbeat. Treat it as though it is background noise because I'm not interested in that. Is there any way to
Yeah,
do that
exactly.
through the
That's
system?
100%.
Okay.
That's exactly how it works. So if I'm doing a system that doesn't need the heartbeat, then that becomes part of the bounds of what it doesn't need to look at. So it depends on what I'm looking at. So I might only care about birds, for example. So if a human comes by, then and I can detect that it's a human, and I don't, and then next time it learned trajectory that that's a human, therefore it doesn't need to pay attention to that. That's where the self-learning, the EWC, and other components come in, because once it's determined it, it never has to look at it again to understand it. Right? I learned the first hour what a heartbeat was, but I also was told that heartbeats aren't important for what I need to do in this particular scenario. I'm only monitoring the vibration of a pipe. And if the vibration of that pipe changes, that might indicate a leak in that pipe. Now, in that scenario, I don't care what the heartbeat is, right? It doesn't mean, it's not meaningful for the signal that that's important to me, which would be a potential or leakage of a pipe, which means the vibration of that pipe's slightly altered. Now, in the vibration of a pipe example, there's a couple things you would have to note as well. The temperature of the water could affect the vibration. The amount of water flowing through that pipe, given someone's taking a shower or something. So there's all these other things it needs to learn and understand to realize what the vibration actually means. But generally speaking, it's learned that the vibrations, through certain characteristics, aren't that meaningful. I don't really care about it. So if something's now suddenly outside of the typical operational bounds, it jumps into play and says, well, you've got a leak in your pipe.
Can you do this through just like prompts?
No.
No.
No. It's trained models. You can interact
Okay.
with the system to train the models through prompts. So when I showed you this earlier, I've already trained the model in my office, right? Been doing this for months. So in this case, I asked what was Stewart's see what would blow his mind. Let's say John instead. So gesturing shifts, motion energy, I can pick up on movements of arms and things, breathing, heart rates, stress levels. This stress level thing, I don't know how exactly it works, but it does. It literally for a day it was sending me messages every time I'd have a stressful call, which was interesting. It totally nailed that. Various forms, it's saying how far I'm away from my node, which is exactly how far I'm away from it. So it's picking up my printer. Like I got an HP printer. Yep, I got an HP printer. So it can dissect the other RF signatures in the room, right? It's just kind of crazy. Now the part that you're asking is like, I'm asking Claude. Yes, I interact with my library through a kind of conversational approach, but the actual tech that's making it work is not Claude. Claude's the interpreter, right? It's just telling me what this all means, but it's the ultimate interpretation is the model that's driving it and the ESP32s that are connected to it. But I can connect all kinds of other sensors to it as well. This just happens to be RF.
A
So
quick dumb
yeah.
question. Apologies. Do you have to join an access point in order to access its Wi-Fi signals, or can you do
No.
this? Okay, so
No, so for this, again, it depends on what you're doing, but for the way I'm doing it, I've got these seeds that I'm building. This creates an ad hoc mesh network. So I've got seeds and seeds. So I connect, all these devices together, right? And these devices then form an ad hoc network. So these are separate from my main network. And in this case, I might not even give it any internet. I don't need any internet. They just provide the mechanism for all the various devices to communicate, learn effectively together. So I can offload the more computationally heavy elements in terms of coordination and learning and other components to the seeds. And then I use the ESP32s purely as a kind of sensor array.
So the implications here are that, like, if you're in a high-rise building, you're not limited to your Wi-Fi. It's all Wi-Fi that's visible.
Oh, you can borrow the other tenant's Wi-Fi to amplify yours as well. So not only can you, it actually would work. It would work better in a RV, a RF heavy environment. The system has the ability to I don't even know how to describe it. I'm probably not going to do it justice, but basically it can intermingle with other RF signals and then use the phase shift inversely of those signals to measure your environment further. I don't know exactly how it works, but all I can tell you is it works amazingly well. So the more noise you have, the better it seems to work. So an apartment building is actually probably better than, being out in the country by yourself, which is a little weird. Again, negative space. So the more it's happening in and around that negative space, the better it performs. It's looking at the void, if you will.
Yeah, that makes sense. It's scary but fun.
Yeah, it's not scary in the way like a lot of people misinterpret this as like it's seeing me naked in my no, it's not. That's not how it sees you. It sees you as an electromagnetic signature. Now, if that some might call that your aura, some might call it your soul, some might call it your electromagnetic signature, but it isn't a picture of you in the same way that you are seeing me in the physical form that I take when looking at a picture or video of me. It's not that. It's different. It's fundamentally different. It's like this wavelength that we can't fully interpret, right? It's this other, I don't know, other dimension that we exist in, but we can't natively see.
It's outside of our sensors, so that kind of frequency.
Yeah, it just makes me
Correct.
paint my entire unit in lead paint. That's what it makes me want to do.
The lead paint's not gonna it's not gonna solve that problem. Well, maybe if you do heavy lead, coated walls, but and that'd be actually interesting to study the because lead emits all kinds of interesting frequencies. What it's doing is it's studying the in this case the electromagnetic signature, but it's also studying things like the frequency of things. So if you have a sensitive enough sensor like one of those RV diamonds, you can sense really like femtoscale vibrations. Remember, everything has its own sort of vibration. Like think quartz versus diamond versus ore. Each has a frequency in which they resonate naturally. The system can pick up on those natural resonance, even if it's femto level. It means that you could drive around looking for mineral deposits. If it's decent enough size and you get a sensitive in a sensitive sensor, you're going to be able to find those things even from afar. It's kind of crazy.
What's the best one to buy, Ruve? The sensors, because I couldn't find the NV Diamond anywhere anymore.
Yeah,
And
I think they might have been banned. I should have kept that to myself. The 60 millimeter. Where did I put that? This one. This is a 60 millimeter radar. Cheap, $5, AliExpress. And what this does, this requires line of sight. Let's see if I can plug this in. You guys have a minute, I can plug it in and get it going.
Sure.
Let's see here. I've been having some USB issues because I got too many ports. All right, so this turned on. Now I'm gonna probably have to unplug one of my ESP32s. I think I've got conflicts, but we'll see if I can get another COM port. And this, to be honest, this works better on Mac. I've been moving most of my hardware engineering to Mac from my PC. I just connect to it remotely. All right, so on a PC, to see your comms, you type mode. Yeah, we're still not being picked up. All right, let's try something else. I'm gonna unplug this. All right, then I'm gonna attempt. So now just to confirm it's not seen. Take mode. Yep, COM port 9's gone. I'm having COM. What I need to do is reboot. I'm just too lazy. All right, I'm getting power. Now the question is, can I pick up the COM port? Mode again. It's not being picked up. Yeah, that's the same problem I was having earlier. Let's see if I can get this. I'm going to plug the ESP32 back in. And by the way, on ESP32s or Pis or whatever, generally speaking, you want the left plug. If there's two plugs to plug in, generally speaking, the left is the right is the correct plug. Just the right typically is power only. The left is generally the power plus data, is what I've discovered of hacking these things over the last little while. All
Power
right, so
over
what?
Ethernet, so that's PoE, right?
Yeah, that's what Mark Templeton keeps bugging me to do PoE. He loves that spec. All right, here we go. What do we got here? I've got lots of wires. So what I'm going to do, I'm going to take this and I'm going to plug this into my seed. So, and then I'm going to plug the seed into here. Oh, I need another wire. Here we go. Maybe this one will work. All right. There we go. So this, and you can use the GPIO as well. Now what I need to do, because I think that's on a Wi-Fi mesh, then we got to go and see if I can find it on my Wi-Fi. So this is going to be probably 192. Is it finding it? Not yet. Let's see if Claude can find it. I plugged, and remember, it takes sometimes a few minutes to start up. I plugged
Now,
in.
one of the caveats for everyone is it's got to be on a 2.4 gigahertz, right? With a password.
It sets it all itself up by itself.
Okay, that's fixed from the
yeah,
retreat.
Yeah, it same thing. It creates its own network. In this case, it creates its own Wi-Fi network, so you don't have
Oh,
to
we're
worry
not
about.
connecting to an existing. Yeah, I see.
Yeah, exactly. Right now I think it might be behind my firewall. Let's see if I can find it. All right, might have to do some configuration. So now I'm on my local machine. I'm gonna go here. I'm gonna create a new DSP quickly. And I'm gonna explain what I'm trying to do. I've connected a 60 millimeter, was it 60 MHZ, I think it is. I don't even know what the heck it's called. I don't know. It's 6 MHZ radar to my seed, and the seed is on my Wi-Fi. Can you see the you know what? I'm gonna if I connect to the Wi-Fi, I'm gonna disconnect from my Zoom here because my network would then be on this. Let's go to Mac. Well, I'm gonna lose network there too. All right, here's my problem. I need a mechanism to connect directly. I've got to rethink this a bit. Here, I'm gonna stop for a moment. I gotta do some thinking. When I do this normally, I don't have to worry about losing my network because I'm not on a Zoom call. As soon as I connect to my Wi-Fi mesh, I would lose the internet, but I would be able to communicate with the system. All right, sorry about that. Let's see if I can. Too many. I'm gonna have to daisy chain possibly a multiple. That could work. Yeah, let's do that. New idea.
What about a hotspot on the phone? Does that work?
Oh no, it's not. I got plenty of hotspots. It's the fact that I'm in this case I'm creating a new network. Now, in order to interact with that network, I'd have to connect to that network, which is a Wi-Fi network. And as soon as I connected to that Wi-Fi network, I would essentially lose my connectivity, right? and I would no longer be talking to you because I'm on a different Wi-Fi network that doesn't have any internet. But I would be able to communicate with all the parts. So what I need to do is set it up so it automatically loads when I plug it in without me having to figure it out, kind of thing. And then I maybe put Tailscale or something on it, or give it like my actual internet access. I don't know. It's always a networking thing with these sensors. One sec, let's see here. So I just plugged in my seed, by the way. And here, let me show you what that looks like. I'm going to ship those next week. What I'm doing is probably I might do a hacking Zoom call when we all get when I ship these out. I'll walk you through anyone that's ordered these. But once you plug it in, you get the C drive. So the C drive includes a few things. Now, if you want to use my SSL, you're gonna have to enable the SSL cert. If you don't care about that, you just go here and click open. And then what that does is it checks for the environment. So once it connects, you can see that I'm not using SSL here. So this has been running for a while. So this is telling me my temperature and whether it's paired. Now, if I want this to run in a mesh, I can go down to Wi-Fi setup, and we can scan for networks. So this allows me to connect to existing networks. Oh, why is that not?
And Rue, for some novices, it's the easiest way to use terminal and then install Claude Code to help out.
Yes, it's an MCP. Yeah, this is everything you see here is an MCP. So in this case, yeah, so this is exactly what you do. So here, I'm going to show you. So I'm going to go back here for a moment. I'm going to go to find my here we are. So this I'm going to say explore. I'm just going to give it the address and and tell me what the seed can do, something like that. Now I've already gone ahead and configured it, so I'm just trying to see what's going on there. Oh, I don't have a network connected. Scan. Or maybe I have a bug. There's always a bug. Let's see if the pairing works. I'll go back at the top. Not authorized, so not paired. That's my problem. So I'm going to pair. There we go. Now it's paired. Now I should be able to run. Yep, that works. Run. Yep, that works. Let's go back down to the network and see if that's the problem. There's a lot of moving parts here. But yeah, I could have done this. We're getting 0 networks. That's interesting. Gonna have to. That might be a bug. All right, we'll go back here. So basically now Claude's just taking a look at it, saying, okay, what can you do with it? Let me just ask it. The seed isn't. Oh, I'm on the wrong one anyway. I'm not gonna do it here. I should have. But if you want to take a look yourself, you'll see here that there's a README file. The README file mostly isn't for you. It's for Claude just to see what it is, but you can open it as well. So it just tells it how to use the system. And then there's a status. This is what gets written the first time it runs. Again, this is information relating mostly for Claude. This drive is read only, by the way. You can't actually save to it. Right. Let's go back to Claude and see what it's learning. I don't know if this is interesting for any of you guys. All right, here. So I just Cognitive Seed Edge Intelligence appliance. It's running on the V2. Yep, Pi. That's the Pi that's running on. Vector store, thermals, reflex arcs. At this point, if you got sensors or whatever, you could start connecting them up to it, and Claude's going to guide you through the process. It's Claude first tech hardware. If you can think of it that way, right? It's hardware meant to be hacked by Claude. Like there's an MCP server, does are you able to scan for networks? And I'm not sure why that network was failing. So I got it.
So the IP address is assigned, and does it then become
Yes.
is it static then after?
You know, I created a static network, and I created several. I created an MDNS, which is cognitum.local 169.254.42.1, which is a static network address. Now, if you operate in a mesh network, it'll optimize itself, and then it'll then attempt to connect to the other seeds that are in its proximity. I'm not sure what's going on with my networking now that I saw that, and that's going to bug me. The pi is the seed connected. Let's add this. Oh, you're gonna watch me debug. Sorry. When I see a bug, it drives me nuts. Isn't finding any Wi-Fi networks. I'm not sure why. It can't send out my seeds if it doesn't find the Wi-Fi. Anyway, you guys gonna have to watch me debug. But
All right. We'll
you
watch.
get the general. Yeah. So at this point, I can run it in all kinds of different and I can connect to it through SSH, which is likely how I would solve this bug and then update my firmware. I guess if you guys are curious.
Yeah, I'm trying to
All right,
update the firmware right now. So once we connect, we can just tell Claude Code, connect, pair, update the firmware to 0.0,
No,
0.1, right?
The old version is probably I'll have to give you a flash. You're probably gonna have to use a flasher to do that on the ones I gave out a couple weeks ago.
Oh, okay.
But once you get the most recent version, it'll start working. It's just you got a really early prototype.
Sure.
I've made a whole bunch of changes. Like I don't think your prototype includes mesh networking. So there's
it's telling us the over-the-air script. It sees it, it's aware of it, it just can't seem to push it.
Yeah, exactly. It's
okay.
But I can send you an image, and then you would have to you'd have to take out the SD card and reflash it. So, one of these sorts of things that
that's fine.
It'll take 10 minutes.
Fine. So should we be using a series of these sensors? Because you mentioned the 16mm sensor. I just want to, if we're going to buy a packet of sensors, it'd be good if we all knew what to get. So what we could get would be tested. And you're saying you're running all night and you're modeling it. Do we need to model it to us? Will the next version that's flashed come to us and have the intelligence you've built into it? So now when we plug in any old sensor, it'll pick it up and immediately synchronize to it, know how to read our heart rate. Because that was a challenge Mark and I were having in Vermont, was the ESP32's 3S's weren't synchronizing and they weren't reading our heart rates at the right level. You clearly have much higher fidelity.
Yeah, that's because I've updated the review system substantially since then. I trained a model on it. Yeah, so you just need to use the most recent review updates, and I've got a model that I published earlier. So yeah, I'm getting way better fidelity now. Now I got a mesostatic mesh, and the version I was showing you a few weeks ago, it wasn't meso, it was much less fidelity. So yeah, I've been greatly increased the fidelity, and tested on a whole lot more ESP32s. Yeah. Yeah. All right. I guess anything else anyone wants to cover? It's 1:30.
Is there a place to find the new image? That's all.
Yeah, I'll create a GitHub repo, like a release, and then I'm able to create a flash. It's something that flashes your drive for you, like a little desktop app for Mac and
that would be great.
And maybe if a couple of us, if we find out someone finds some good sensors, maybe we'll share those as well.
Are we creating a separate WhatsApp channel for cognitive? So anybody doing cognitive one can, or has the seeds, can track on that and compare notes?
Yeah, I could probably do that. Maybe I could do a Discord. WhatsApp's a little hard to manage,
That's
but
fine. Then
you know,
Discord, whatever. Just let us know so we know to link to it, and that's where the GitHub repo is, etc.
Can you talk about Pi a little bit more?
my Pi brain.
Yeah.
Yeah, which is currently down. Let's see what's going on there. I've been feeding it the common crawl, which crashes it. I might have overdone it. But basically, it's all the learning things I was showing you earlier as a kind of MCP enabled service that constantly learns, adapts, understands. I'm feeding it essentially common crawl data. I think I'm at like 18 million connections at this point, so it's getting quite substantial. And then I can interact with it. And what have you learned today? Kind of questions. But the problem is
I'm sorry, do people using Cloudflow, do you have data going into that, like from the agents?
No, I don't. I thought that would be a little bit overly intrusive.
Well, I mean, have you thought about asking if people wanted to participate in running their?
Well, right now I'm having some scale issues, so I got to figure that out. It's been crashing on me, so I have to figure out why at this at 18 million records it starts to crash. But
And
that
some
could
of
be.
us started adding some stuff to the Pi brain also.
Yeah.
Oh no,
From some
I'm
of
feeding
our
in.
systems. So.
Yeah, I'm feeding in a lot more data than that. It's me for sure.
And so, sorry, Roof, just to finish our prior conversation, it updated. I just had Claude Code. I said, work with it, do whatever you need to. It took it from 0.6 to 0.1. I just dropped it in the chat.
Yeah, point one is the most recent. So my OTA is working. There you go.
Yes.
No flash required. All right.
No flash required. So that was pretty slick. So I put the
yeah.
instructions on what it did, if that's useful.
Yeah, now I found a bug in point one that might be affecting it's not scanning my network. It's detecting networks that could be interfaces. No, it's I'm sure
Rube, I don't know if you. Oh, I'm sorry for interrupting. I don't know if you know, but in case you don't know, after you verify that site is like safe and everything, that I found it doing research for like the latest silicon chips for like measuring your environment and like computer brain interfaces that are like I don't know, the chips on there are like $12 and $20, and they're like very good silicon chips that are new. I'd like to hear your opinion on it, and maybe you could use it for your projects when you get the chance.
what I'm not sure what chips you're referring to.
I don't know. They have so many new chips it specifically measures like I know your PAR measures photons in your environment, but this is measures wavelength. And I don't know, they have so many different kinds too that are.
If it's a sensor, then chances are it's useful to us. Like that's all I'm doing. I'm taking random sensor noise and sensor data from any source I can possibly get, and then saying, "Hey system, what does this all mean?"
I think he'll like those sensors that they have, unless I'm like behind already, which I thought. Hopefully, I'm still in the present.
Oh, actually, I know what the bug. I think I know what my bug is. Stu, since you're connected, can you see if the scanning for Wi-Fi works for you? I think I'm connected to some random customer VPN, which blocks my scanning.
So I just say, do the scanning for Wi-Fi work?
Yeah, can you find any Wi-Fi? If it doesn't work for you, then there.
The scanning for it seems to be scanning. Yeah, found 11 networks.
All right, show me yours for a sec. Okay, here's my problem. Like this is like boohoo problem, by the way. I've got too many enterprise customers for giant companies that all make me run through their random CrowdStrike Palo
Right.
Alto, blah, blah, blah VPNs. So I literally have like 10 different VPN softwares that I jump between, all of
Yep.
which are screwing with my network. I need a
Yep.
computer just for like random giant company.
Sharing's turned off, so I'm trying to share, but I can't. There we go. Okay. Number 2. Here you go. Okay. Can you see?
Yeah. I see command line in your chats.
Sorry, am I sharing the right one? Damn.
You might be sharing the wrong screen.
All right, hang on.
I think I need a reboot.
Yeah.
I think I've
No,
I think
I'm
I've
sure.
I think I've messed up my networking to a point where it's requires that my COM ports aren't showing up correctly, and now I'm not finding Wi-Fi networks. That I've taken it too far. If you don't screw up your computer once, you're not doing it right.
Right. Okay, so trying to share again. Now do you see it?
It's a dirty site. No, I'm just kidding.
No.
Yes, it's you're good. I see it.
Yeah. So all right. So here you go. So what I did initially was tell it pair because it wasn't pairing, and now it's paired. And then I asked. I finally got it to update from 0.6 to 1.0. Let me make this a little larger so people can see.
Yeah. So 1.0 is my most recent version. I published that like a day ago.
Right.
And
So
so
the good news is how it connected.
Okay.
And then what's new? And then I just asked it what was new, and it gave me that. And then you said, does the Wi-Fi scanning work? Yes. 11 networks found. You're connected. Here you go.
Perfect. All right.
So
So now what
seems to be working.
You can open. So go to your file explorer on your Mac there. See if you can see the USB drive. You should see Cognitum as a USB drive somewhere.
Yep. There you go.
Okay, select that and then choose open.html. Just double click it.
The guide?
Yeah. Open.
Oh, open. Sorry. Yeah. Okay.
All right. So I'll select. All right. So now you're on the unencrypted. Now, if you want to enable the encrypted, you can go. You see that launch command option in the drive? Click on that. Yeah. Launch command. No, the other one. Launch command. All right. You should see a little. Now that
I should see it popping up in a terminal script somewhere.
No, it should. Yeah. There we go. This is
Launch
enabling.
command.
Yeah. So what this is doing, I created a custom CA. This is enabling HTTPS. Yeah. So you can close that up. Now in your browser, type in 169 HTTPS.
That's it? Oh, sorry.
Yeah, that is it. Yep.
That's it. Right there.
Hit refresh. Hit refresh. You're still your cert still isn't working. Maybe try a new tab possibly.
Sure. And typing in what? 169?
Same address as copy paste it, yeah. With the HTTPS and the port.
Right. Good point.
The problem isn't without it, and you need to just go back and grab the port, yeah.
Got it.
Now if this doesn't work, which it doesn't look like it's going to work, go back to Claude. There's so many different networking variables. It's really hard, especially with certificates.
Yeah.
Tell it to review the drive, whatever drive it's on, the cognitive drive, and then like just drag a file from there, from your drive, just so you know what the location is. Yeah, and then get rid of the launch command thing. Just the end there, yeah, and tell it to enable the SSL cert. Yeah. So the reason I did the drive, because it's a quick and easy way to just point it out where it needs to learn and do everything it needs to do.
I understand.
Now I'm also creating networking and a bunch of other things.
And I've got the drive opened here.
Oh, okay. So yeah, I would have already known then.
Okay.
Sure.
Already installed
Earlier.
CA cert. Chrome
Oh,
off.
Chrome needs yeah. Okay. So don't worry about it.
Okay.
All right. So the next thing so you're on a Mac. What kind of Mac do you got here?
M3 Max 128 gig.
Perfect. So, one of the best uses of this platform is to train models with it. So in this case, you could ask it, how can I use my Mac and, the seed to train the optimal model for something? Like, you tell me the problem you want to solve. Yeah, for something amazing that'll
like Mela.
Yeah, exactly.
Okay.
And again, it's going to learn and it's going to work with it, right? So you're offloading and having this as a kind of augment to certain systems. So you're exploring, right? Saying, okay, data collection, training, Mac pulls vectors, embeddings, the seed, training models. So you're using it to optimize. Now it's particularly well suited to optimize for learning signals, right? So ask it, what kind of signals can I get from the seed? Because there's a bunch of stuff on the seed already has on it, like yeah, like I think you can get some presence.
And my Wi-Fi.
My Wi-Fi and any other available. Yeah, exactly. Now, do you have a ESP32 around?
I don't. I lost it in the box. So I have the seed, but I do not have the little piece to plug in. But I'll pick one up.
Yeah,
that's why I was asking. I'd rather buy a better one because those didn't work too well, the 3Cs. So I just wanted to get 3 or 4 good ones of something else.
Yeah, get these little Heltechs.
Get the which one?
These little Heltech ones. They're pretty good. It's going to ESP32 Heltech, HELTEC.
Okay.
And they get a little screen. You can, this is what Matt and I were using to do like disaster detection, like people are collapsed in buildings, kind of thing. But they're nice. They got a nice little antenna on them. Right. So physical sensors, vibration, etc.
So I couldn't use this to do heart rate yet because this couldn't do it. I need the ESP32 to pull the heart rate off the Wi-Fi.
That's a good question. I think the CSI is directly ROM related. Now we can ask, can we do CSI using the seed directly, or do we need an ESP32? To be honest, I never tried. Interesting. I don't think it natively. It means I'd probably have to write new firmware.
Well, that would be pretty cool if you're adding something to it.
When I eventually
in all your free time.
Yeah, exactly. In my free time. Like today, you got me for a bit. I've got lots of free time today.
Question: powerful. Wait a minute. Let's check with the Wi-Fi chip the seed has. All right.
I don't think it has it.
No, you need an ESP32 proper CSI. Okay.
Ask it if you could create could we create a secondary Wi-Fi network and firmware
to do what?
For CSI. It might be
just like that.
Yeah, it's probably ROM. It's probably core of the ESP32 operating, and we don't probably have that kind of level of access.
Okay. So is the issue that the ESP32 pulls different CSI signals from the Wi-Fi than the seed can?
Yeah, so the ESP32 is doing channel state directly as part of the Wi-Fi radio that's on the chip itself. And then I'm using the flux in that. Okay, so it's saying what we already sort of know. The seed will do the pipeline. It'll fuse the onboard sensors, which is the seed is essentially a really smart sensor signal processor. But the hard work is offloaded to other things.
Okay. Anything else you want me to do it? But it's
No,
nice that it updated without you having to send out flashes or anything else. That was pretty slick.
yeah, so that's working. And I thought it wasn't working. So that's good news.
Okay. And I'm just going to ask it what else to find. And hopefully it gives me the health tech. If not, I'll try to find it somewhere.
Ask it if you can connect to the device via SSH. The password's cognitum, by the way.
The sweet spot, ESP32S3. It's still like the S3, but I thought you said definitely don't get the S3. It's underpowered.
S3 is, no, definitely get the SP. S3 is what you want.
What did we get initially?
S3 micro, you don't want.
Oh, got it.
Okay.
Okay.
S3 micro works. You just need a whole lot more of them. It's telling you where to buy. What's the sales pitch? Scroll down a little bit. See.
$13.
SSH.
Great.
All right, so you can scroll down a little further. All right,
SSH is working.
Yeah, ask it to connect. Tell it the password's cognitum.
Sorry, connect to SSH what?
Connect to SSH using the password cognitum. You can change this password too if you want.
Uppercase, lowercase.
It's always lowercase. Actually, it's right where it says above.
Got it. Sorry.
So once you're in, this is a little Linux machine. So you can customize it further and change out the passwords, secure it. So the default password is incognitum. What I generally do is I add my SSH key so I can just connect it without having a password, and it only works for me. All right, now that you're inside the seed, you can start doing things in the seed as well. Okay, hey Claude, what can I do inside the cognitum seed SSH? You have no idea how exciting this is for me to see it working on someone else's machine. I'm the sole developer, the sole QA person, the sole salesperson, the CTO, the consulting guy, in every other position, and all the guys, Roger, who's working on the chip. So I don't want to bug him too much.
Yeah.
So it's I'm essentially the entire team.
So one suggestion is you might want to sell it with the ESP32S3 so that when somebody gets it, it's more useful than just itself.
Yeah, we were thinking about potentially
No, because the ESP32s are very very wide variety, different types of them, like Heltex and racks, and there's just so many different varieties you can get. They should have like a guide or tutorial on like what to learn though, so you can make the right decision that's best for you. Pick the chip that's best for you.
That's the problem with this. I know what people really want, and it's not likely the seed. They want this. They want the appliance. This is the brain in the box. This is everything. This is like you can funnel the other day I was taking all the output of my screen, including audio, video, everything I'm doing on my computer, feeding it to this box, no internet required, and it's learning about everything I'm doing. And then I go to the box and say, hey, didn't I have a conversation with Stu last week where he said something? Oh, and it remembers that. And then it can send me notes and messages. It can learn my breathing patterns while I sleep, everything without ever going to the network, all in the box. This is going to have a 7-bit MPU array in it and a bunch of other things. And eventually, when my chip comes out, it'll be in there as well. It will be one box to rule them all. This works alongside this. So these two work together. Signal processor, brain. Nervous system, brain, if you want to think of it that way.
Okay. Anything else you want me to do now that I'm in?
You're in. Yeah, you can do what else?
I don't know. That's my question.
I don't know. To ask it if you how can we integrate the Neurotrader system to help us trade high frequency stocks? Now you might want to point.
Wait, ask it to integrate PieBrain?
Or PieBrain, or yeah, exactly. So in that case, you're going to want to point it at my root vector Well, and is PyBrain back up again? Let me just check that, get it back up again. I got too many windows. Where?
Yeah, I actually had a quick question on PyBrain. Is the expectation that we all have our own local PyBrain, or that we should all use the centralized one? What is the best outcome?
The centralized one is for common knowledge. Generally speaking, I use it locally for my own stuff, and I don't share it publicly. And that's like personal stuff. My own little second brain of I feed it all my emails, and literally everything I do on my computer flows into the brain. Now I don't share that publicly, and I obfuscate.
Ruflo gets confused, just so you know, between MCP brain, something or other, server, and PyBrain. It was definitely getting confused. That's why Mark and I come up with this idea of the Root Vector catalog. The conversation we had with you Friday night when we were asking about how come we're not seeing all the cool stuff inside the Root Vector that you have, and you use RootDB, which has kind of all your knowledge built in there, but we don't have it. And I've done half a dozen deep dives, and it still misses all of the stuff in the depths of the crates and everything deep dive into Root Vector. So it'd be great to surface some kind of intelligent catalog of all the elements in there the next time you do a rev of Root Vector.
Point it at the ADR. That's how I do it. My again, I don't point it at my code. I point it at the ADR folder.
Yep. Now tried that, and that's why we ended up coming up with the Root Vector catalog, because we did it to do that and do an exhaustive thing of all of them. So now it seems to be finding it, where before it was finding like 50 of the things as opposed to 200.
Yeah.
Okay. So what is this telling us we can do?
It's saying you can do a learning system that will learn how to trade, and it'll use the seed to basically execute your trades. Now, in this scenario, this is how a lot of folks are like, how do I create a neurotrading model that doesn't break the bank? The seed is the trick. The seed is monitoring the flow of data, right? And generally, to John's point earlier, it's dormant, and occasionally something happens where the perfect trade opportunity appears, and then it'll execute the trade. But it doesn't have to run in the cloud to do that. You just keep this plugged in, and it'll just go and do the trades every now and again. It can so you could escalate it to like I would probably escalate it to like a cloud function on Google or something. And then when the certain metrics are made, it then goes and does the trade for you.
Okay. By the way, did you remove the ability for people to write to PyBrain? Because yesterday it told me we needed a different API key to write to it. I didn't know if you were doing that
Yeah, I
because
did.
it was
I
getting
changed
clogged.
it. Yeah, I changed it. It was being over. I think it's mcp.py.io. I don't know. Where's the?
So do we need a new API key, or should we just not be doing it until you finish your common crawl?
I know I'm just messing around with it. I don't know. I had to change the location.
Okay.
I probably need to rethink the API.
Okay. But so this is connecting to PyBrain. And that should make it significantly smarter, right?
Yeah, exactly. And you can make your own brain, and you could do your own trades and whatever it is you want it to do.
That's exactly what we want to do. That's what, as you know, we're trying to do on the May 8th and 9th.
Yeah, it's still looking at the old location.
Yeah.
Hell yeah, I have like over 3 years in quantitative trading in cryptocurrency. So I'm looking forward to utilizing NeuroTrader to the max.
Yeah,
Go ahead.
one of the things I will do, I would suggest, like the way I use it, I stick it on my appliance, and not the seed, but I actually put it on the actual appliance, which I don't have available yet. And then it just runs on that all the time, doing this various trading, and it doesn't cost anything.
Okay, that makes sense. Thank you.
Yeah. It's the location of the API changed.
So what do I tell it?
I'm gonna have to rethink how I deploy this.
Okay. anything else you want me to do here? But it seems to be working and connecting and doing stuff. So that's encouraging. I think one of the questions people have, Rube, is we understand that it exists. You seem to have a very clear sense on how to use it, how to get value out of it, how to run Wi-Fi dense posts with it, et cetera, et cetera. And to a lot of us, we understand that those things live in the bowels of RuVector, but it's a little less clear how to use that in here, what to do with it, and when we should run that on our local Mac, when we should run that on here on the seed. And that's where a little bit of the confusion comes.
Yeah, well, I get that. I'm the guy that built it. And
Yeah,
it's hard to articulate sometimes.
Right.
But
And I think that's where you're getting some of us saying, okay, I have it. I'm not quite sure how, where, and when to use it versus just running RuVector in a directory or a sub on my Mac.
yeah,
That's a
exactly.
good question. Is there anything that the seed is specifically optimized to do? Because I wouldn't want to clutter junk on my seed, you know?
It's well, it's meant to I've optimized it specifically for review, and that's
in
predominantly
RuVector or RuVector
well,
is
yeah,
very big.
well, it's a subset of RuVector, but like specifically, what am I using it for? I'm using it for sensory data, which is specifically my RuView system. So essentially, I'm
Yeah,
using
that
it for
makes
like
sense.
what's like shipping
it.
containers. Like think of these sitting in a shipping port and saying what's inside of each of these containers, but it would actually have to look inside the containers, that kind of thing.
Okay, that makes sense. Basically, to simplify your answer is like whatever gives it more capabilities, put it on the seed. Like if it's an eyes or like a wavelength sensor, put it on the seed to give it whatever it needs to see and feel and hear.
Exactly. See, and I've included a CNN on it, so it can do visual, it can do audible, it can do textual signals, it can do wave style patterns, so things that involve frequencies and waves. So and then it can interpret that data.
Oh, that is beautiful. I actually got some gene testing done because of you. So
Yeah,
thank
gene
you.
testing. So hypothetically, if you wanted to do DNA analysis on thousands of people all at once, that's the approach you would take. So let's say you wanted to go and monitor the sewage and say, I need to do DNA tests on a million people, you'd have a cluster of these things set up and would do daily analysis of the sewage, looking for DNA patterns and things, stuff like that.
Okay.
Rovell, you thought about long-term power outside of USB? How could that work?
Find a battery pack,
Yeah.
plug it in. Yeah.
Solar, some type of.
Sure, it's low wattage, so it's it'll run on solar as long as you have a battery pack, the lithium ion nearby, kind of thing.
Okay.
I often plug it in just to a lithium battery. I don't know if I've got one handy, but yeah, that's all it's doing.
So, but it can't do the Wi-Fi dense pose without an ESP32, right? That's why you were saying it needs the ESP32 for CSI.
Yeah, it's
okay. All right. Well, it's connecting to PyBrain.
Yeah, I just enabled it for you. I disabled the API.
Oh, thank you.
Your real-time debugging. While you weren't looking, I told it to re-enable the API.
Oh, thank you. Okay.
Yeah.
Anything else you want done while we're here? Just to.
My problem is I'm where are you connected to? I cheaped out on the Google hosting. I just need to add a better server.
Is that all it would take, and then it would not keep bombing out?
Yes, that's exactly what it would take. Yeah, I'm using Cloud Run. Not good. Short-lived servers. I might want to use. Maybe I'll switch it to Fly.io or something, which is cheap and will run forever. Self-hosted.
That would be good. Now, at this point that it's connected, would we be able to just ask it, what's the latest developments or news from PyBrain?
Yes, exactly. Well, like what's the most recent discoveries? And it's always crazy stuff, like, random planets and stuff like that, but
we can just call it PyBrain, right? We don't need to keep calling it py.rube.io.
Yeah, exactly. The brain.
Okay.
All right, what I'm gonna do right now, I'm gonna give it a long. I'm gonna actually switch it to some decent hosting.
Is that going to take us offline, or you're just going to do it
No.
behind the scenes?
I'll do it behind the scenes. Well, when it goes on, it crashes occasionally right currently, so it can't be as bad as that.
It's better anyway.
Yeah. Yeah.
So Neurotrading is in RuVector. The RuVector is not on this, or it is on this. Like I don't see anywhere on here the actual RuVector repo, but
No,
you're telling us it is.
I've got to. No, it's not. It's an integration. I've integrated it. It's in the examples folder. Now the examples folder doesn't include the it generally isn't included in the ADRs, just to make it confusing for you.
So at this point, if we wanted to do Neurotrading, because it's saying here's ADRs, etc.
Oh,
should
did
we
okay.
be
Yeah, ask it how to use ADRs 86 and 85. And I want to, I don't want to lose my shirt.
ADR? What was it? 86 ADR.
If you make it
85, 86. Yeah.
If you make a ton of money, it's 100% me. If you lose out all your money, I had nothing. I had
100%
nothing to do with it. That's all on you.
I guess my question is right now, where is it pulling these ADRs from? The Pi brain?
Most likely. I fed it all my ADRs. Well, most of my ADRs. Yeah, see the Pi brain ADR? So it's getting it from the Pi brain. This is exactly why it's so useful.
So it's saying that the Pi brain is now pretty heavy on Neurotrading. Have a bunch of people been doing that? Because I know you didn't originally throw that in there. You threw in everything, but you didn't have it focus on Neurotrading.
Oh, well, I do my own Neurotrading, and as I do it, it's been learning. So it's learned. It's again, use at your own risk, blah blah blah. But it is learning based on what I'm doing, and I don't like losing money.
So you're basically only looking for things that have a very high likelihood of positive execution.
No, that's not all I'm looking at. I'm looking for fraud, and I'm shorting.
Oh, okay.
We are in an environment, a fraud-rich environment.
Right.
There's likely I don't know if I've ever seen so much overt financial fraud in all my life. It's a gold mine. All you need to do is find that fraud, short those, and wait. Eventually, all these frauds are going to come to light.
How about arbitrage opportunities?
Yeah, you're competing with every other arbitrager. That's a get-rich-quick campaign. It's like you might as well just bet on sports games. Now, if you do want to do arbitrage, you're going to have to do the high-frequency stuff, most likely.
Right.
Now, you remember you're just trying to beat the speed of light to do the arbitrage.
But you can do that, right? I mean, we're at 54,000 a second, which isn't
that's
speed of light, but
that's a different metric. But depending on you're looking for speed of light, you're looking at packet relay. So certain packets. Remember, most systems have a handshake. The handshake, generally speaking, is on a really high speed network. It's 50 milliseconds, maybe 100 milliseconds. I've devised a system to use quick UDP, so there's no handshake. So right off the top, I can front load just about anything because I don't have any handshake on the request. Now, taking that a step further, I can then do the sublinear time solving and do a whole lot of very strong, fast calculations and no handshake. So I'm faster than anybody else on certain temporal bound trades. So so basically what that looks like, it looks like I'm moving faster than the speed of light. They're just tricks of sort of a temporal dilation. It looks like it's faster than light. It isn't actually.
you realize these calls all sound like a science fiction movie, right?
Yeah. We spent half of it looking through walls.
Yeah, that's fair enough.
Decompiling CLAUDE code, looking through walls, setting up a Neurotrader, you know.
All with a device that costs a couple of $100.
Exactly. Less than a couple
Appliance
$100.
is what, 3 months out, you said?
I'm supposedly getting the PCB next week. So we'll see how that goes.
Okay. And that's going to give us, that's not going to give us 257. That's just going to give us a beefier
No,
setup like
that's
we
gonna
have right
give
now with Seed.
that's gonna give you a 7 array of STM32s with the MPU and essentially a Pi 5 optimized for root vector. Now, if you really want it to go, if you want to, you could go and buy a Pi 5 and attempt to do all the firmware configurations and probably vibe it yourself. I've
No,
just done
thanks.
all the work. Yeah, I've just done all the work.
Yeah.
Eventually, we're gonna for the seed, the seed will be replaced with the chip. At which point, I go from like dual core or quad core to 257 core and like 8 gigahertz versus a one gigahertz. So it's just exponentially more powerful single machine. At which point, I can run language models, audio, video, whatever, all that kind of stuff.
Very cool. All right. So it's pulling something up here.
It's looking at Binance. But you've got a cognitive trader, Binance blocks US IPs. You might want to use Alpaca. That's Alpaca is probably your best bet.
So tell it to use Alpaca?
You have to sign up for the API and get it, but yeah, use Alpaca.
When using cognitive hardware, are there advantages compared to using a computer or the fact that it's portable?
It's optimal for long running independent things. You just plug it into the wall and it's good to go. It sits independent of your computer. So, a lot of the use cases are industrial, I'm not going to lie, or medical, or things where you need patient data to remain local or learn the signatures of someone who's in, respiratory distress in an ICU, vibrations of pipes, electrical signals from industrial systems, CNC machines that are about to break before they break, that kind of stuff. That's the predominant use cases for it, this could be in an environment where there's no internet required, so it's exponentially cheaper because you don't have to go and sign up for Google or AWS or whatever.
Got it.
But what you're doing right now is exactly what you need to do.
And how do we keep it stable? If we unplug it, how much of this goes away? How much do we tell it to store it? Is it automatically storing it on the seed? Is it automatically persisting?
It's persisting. As you noticed in the V6, it wasn't persisting. As soon as you went to the V10, the persistence is included, and you can tell it how to persist. You've got I think 64 gigs of storage space in that thing, so that's a ton. Yeah, it should if it's using the API correctly just persist just by itself. But yeah, you can double check.
How do we get the weights you were talking about earlier for the frontier models that we're using to complete our tasks that we can then plug into open source model?
It's on my Hugging Face.
It's on your Hugging Face? Okay.
Yeah, I've got a couple. I call them Rube Ultra,
Okay.
and those are my models that I use for my brains and whatnot. And here's a link. And then I just published a model today for review. Where the heck did
So
I put
Polymarket came up. Calci came. No, Calci needs an API key.
it?
Okay.
Where did I put it?
Wow. So at this point, what are we getting from running it on the seed besides the fact that the seed is not using our Mac? Are we getting a lot of value from running this on the seed versus just running this in RuVector on our Mac?
You run it either place.
Yeah, I understand.
Again, no, it's, my seed is both figurative and literal
Sure.
seed of the company. So more than anything, you guys you're helping me get the company off the ground. It's a seed, it's a token a little bit. Yeah, you can run the whole thing on your computer. Right? It's unless you're doing like IoT related work, most likely your Mac is going to be good enough or better.
Okay.
Yeah, so if you're doing a swarm of ESP32s that need to monitor your room at all times of the day, use the seed. There you go. So I'm not publishing the updates hourly. I do it every now and again. The OTA.
And for those of you that are still on, I showed you my PyBrain key, and I'm just asking, guys, please don't use that. I'm sharing the way Ruve shares with the sense that we're all in the trust here.
Yeah.
Okay. So at this point, this should literally get to the point of being able to build something. So it's finding Neurotrading from somewhere. And since I didn't connect it to RuVector, but it knows that RuVector is connectable via PyBrain, and PyBrain knows how to connect to RuVector. And in the bowels of RuVector is the Neurotrading solution. Is that how it's finding it?
I think it's finding it in the brain, I think.
Right, that's what I said. So, but it's not finding it from the seed. It's finding it because we connected to the brain.
Yes, it's finding from the brain.
Okay.
Which is in itself kind of crazy, given there's 17 million connections in the brain. And then what you can do, once you've got the brain, then you can connect your brain to your trading, and then it learns optimal trading patterns. And then it's always studying and learning and understanding what the best opportunities to make you money is.
Wow. This is pretty slick. And
Yeah,
could we at what point can we tell it, listen, go develop algorithms that are going to give us riskless arbitrage opportunities or things that have a 80% plus win rate?
You probably want, if you can do it now. Create me a model. Like with anything, you're probably going to want to create your own custom model. So you might want to train your own using Ruve LLM, create a model that's optimized for, arbitrage opportunities and integrate it with seed kind of thing.
Okay, so Ru, just a question. So this is based on the new cognitive chip or tool that you have recently made. Since I've been a couple of weeks not being able to attend this, the whole stuff is very intriguing and seems great. So can I buy one of those from Cognitive site or somewhere else?
The seed?
Yeah,
the chip won't be ready till probably later in the summer, but right now I'm creating tools. Basically, some reason people think physical things make my tech real. When they hear about RuVector, like, nah, it's bullshit. It can't be real. It's too crazy. I stick it on a device, it does the exact same thing, and they're like, oh, that's the craziest device I've ever heard of. It has to be real. So
yeah, but just to get on board with the same thing that the Stu is.
Yeah, just cognitive.1 is the site. I'm going to ship these out next week.
Okay, so I'm gonna do something about it. It's
Validate,
been very interesting and intriguing to see that the progress that you have been doing. Great job.
Yeah, is it worth pushing this to a GitHub repo, or is it all just being stored on the seed and therefore there's no need to?
I'm not sure where it's being stored. It's not being stored
That's
on the
my
seed.
question. Is like, let's say it creates this new app. I don't see files getting genned on the Cognitive.
User steward Cognitive trader folder. It's outside of this particular. I see the files above there. It's
Where?
just being stored. It's not in there. It's in your, right
Oh,
there.
I see. Yeah. So somehow on my Mac
Yeah.
over here should be something that has not there though. This would be under my user and a Cognitive Trader folder. Cognitive Trader folder. Look at that. Okay.
Now those files are likely running on, I think they're running actually on the seed because we gave it access to the operating system, which is, it's kind of cool. A little tiny little device the size of a credit card that runs trading algorithms. It's kind of a cool idea. And remember, all the stuff on the seed also has an MCP, so you can integrate it through the Claude MCP tools.
How much storage does a seed have, and how do you extend it if you need more?
It's got 64 gigs, and you take the SD card and stick a new one in.
Yep. Okay.
You're gonna have to flash. You're gonna have to take your old card and flash a new SD card with it, but that's what's involved. If you put a blank card in, it's not gonna work. But I don't know if the seed supports any more than 64 gigs anyway, to be honest. I think it might be limited to 64 gigs. I've never tried more than that anyway.
Probably
All right, guys, I'm gonna jump, but it's exciting to see it actually working.
It is indeed. Oh, here you go. Cognitive Trader. Seeds online, coming online, finding us models. Holy shit.
There you go.
Yeah. Great job.
This is the stuff that when it happens, it makes you go, wow.
And it's using the PyBrain for data and whatever. It's crazy. Remember, I'm feeding the PyBrain Common Crawl, so it's getting tons of updated data every day on whatever crazy it's discovering. So the more, if you start using it for trading, it'll just get better trading.
Right. That's interesting. And I deliberately gave it something very high. I said 80% win rate. It said, let me be brutally honest. That's an exceptional target. Most professional funds would kill for those numbers.
Yeah, you ain't seen 80%. You're looking for 51%, but better just shoot for the moon. Why not? You can call it Artemis 4. That's it. That's all the jokes I got.
Okay.
And you told her to create a UI, Stuart, right?
I did.
Yeah.
I said, give me a clean UI that I can use, and it gave me kind of the trader aesthetic.
Right.
But I don't know what to do with it yet. That's what I would do next and say, which of these are good, but it doesn't matter. That's a piece. But the next thing would be, let's build a model together that actually does it. And gives me something meaningful. And from that point, we'd backtest the shit out of it before we ever spent a real dime doing anything.
And remember, train models. Like your best bet, you've got all the tools to train and learn models. Like, the reason my Ruv view system works so well for me and not so well for anybody else is because I've trained custom models for the system. Whether it's RuView or it's stock trading or some other crazy app, you got to train models for these things. You're not going to just vibe it and say, make me rich. You're going to have to create a model that makes you rich kind of thing.
Ruv, do you have an instruction somewhere about training models in your way?
Yeah, that's a question I had too, because I was kind of on my own doing the Mela training and I came up with stuff, but I don't know it was right.
Ask Claude to use Ruv LLM. And someone mentioned about L4. Yeah, that's what I'm using. I'm using an L4 on G-Cloud. It's cheap. And I'm sometimes using my Mac Mini. Now, if I'm lazy or just don't want to, if I don't want to spend the money, I use my Mac Mini. If I want to get something done quick, then I usually go up to an L4 on G-Cloud, and that makes it easy. Last night I just left my Mac Mini running all night and I trained a new model. That's the model here. I'm gonna post. Did I already post it? I don't remember.
With the cognitive seed connected to the Mac Mini, just to be clear.
Exactly. Yeah. So this model I just posted, the RuView model, that was using a cluster of cognitive seeds and ESP32s connected to my Mac Mini. And the seeds were acting as the optimizer for the training session. So it adds recursion, self-learning, and all the other crazy things directly independently of the Mac Mini. So the Mac Mini can just do what it needs to do with the GPU without any interference, and it works great. And then I clustered them together. I used 3, so and that's how I created the RuView model.
If I get a Mac Mini, is it safe to do a multi-purpose model, or do they need to be specialized? For example, for the
Multi-purpose models generally don't work for anything. Like if you want a crappy model, make it multi-purpose. If you want a good model, make it narrow.
Yeah.
The more narrow, like this applies for anything in life. Do you want a jack of all trades, master of none, or do you want something that's a master of something, but not good at anything outside of that? For me, most of the things I train are good at one thing, and then if I need to be good at many things, I'll create multiple models and have them work together. But I'm not trying to create one model that does everything for everyone, ever. I'm never going to win in a frontier model bake-off. Where I win is like my model can see through walls and Wi-Fi signals, but it doesn't know who the King of France was.
Which means you need multiple Mac Minis to have a specific hosted model. No?
No.
Okay.
No.
Okay.
I only use the Mac Mini to train the model.
Okay. Okay. All right.
Once I've got the
Does
model,
it matter how much memory is on the Mac Mini?
More no, these are million parameter models. It's just a GPU making it fast. Then I take it, I quantize it, and I stick it on an ESP32. So when I'm telling you I created a model, that model is actually running on the ESP32 in 8 kilobytes of space. I created a million parameter model specifically just to run on the ESP32 in that little bit of area they give me in the firmware. And so I quantized the shit out of it. And now, but it took me like 18 hours to train the model. But once I've trained the model, it's and then I quantize the model, then it's smart and capable. I never have to worry about it again.
Okay. And then lastly, Rube, there's a call today at 3 for the folks looking at Mela as a preview before conversation with your buddy Mark on Monday. I just invited you.
Okay. Mark, Mark's obviously a legend. But
yeah, well, that's why we'd like your thoughts on. I want to make sure what we're showing is consistent with what you have communicated, so that the right messages go through and we stay consistent.
Oh yeah, I didn't really communicate much. It's like you got to talk to these guys.
That's well, we understand, but we just want to show you what we have to see if that's relevant.
All right, I'll see you in about half an hour then. Today's pretty quiet for me. You got me today. It's a holiday.
The Ruve Ultra Claude Code you shared on Hugging Face, is that what you're using when you use Claude Code for the learnings?
No, well, I'm not Claude Code. Well, I'm using it as the model for how I do my electromagnetic graph. It allows the system to understand its environment. It's the sort of initial training that it's the jumping off point. Everyone was like, "Oh my God, you didn't give me a model," and so okay, I'll train a good model and I'll let everyone have it.
And I see 2 on Hugging Face from you, one RuView and one Ruve Ultra Claude.
Oh, RuView is for RuView, and Ruve Ultra is for Ruve LLM. So that's the Ruve Ultra is for like that's a coding centric language model. That's like I need to create a language model to understand and interact with the data in my RuView, and I'm too cheap to go and buy an API, from OpenAI or something, OpenRouter. So then I train it specifically for the task in which it needs to learn.
Are you playing with any Minimax, any of the small stuff on Hugging Space that's coming out that's pretty hot? Quen 3.6 just came out, etc.
This is Ruve Ultra is a quantized version of Quen, several flavors of Quen, depending on the Ruve Ultra you're choosing. You'll see that I've got several flavors of Ruve Ultra. I've got Ruve Ultra Medium. Here's if you
can you show us where that is?
Yeah, so I got one here optimized for Claude Code. I got one. This is a small one, just to see how small I could get it. Then we've got, the Ultra, which is kind of my middle of the road, not as quantized. Medium, a larger one. And don't pay attention to depth too. It's something I was mecking around with a while back. But yeah, this is the one I generally use. And it's optimized for self-learning and optimization. So it's a model intended to be to learn and adapt as you interact with it. Right. So I put this on the appliance kind of thing.
Was that just designed to do the model routing? The
No,
Rove Ultra?
it's conversational, but the model, the Claude, the Rove Ultra Claude Code is made for model routing and edits and AST.
So is that running when you're running Cloudflow?
It is, yeah. And interestingly enough, my Rove Ultra Claude Code is the most popular for, I guess I'm just drafting on theirs. So yeah, this is the one that's optimized for Claude Code. I should probably do a new one. I trained this all on, what was the last update I did? 6 days ago, I think it was. Where is it? When was this? When does it say the last update? 6 days ago. I could probably do
How long does it take to train?
Well, I use Google, so not too long. A couple hours. This is a 500 million parameter model. The model I did for the review took 18 hours because I was training on the electromagnetic signature of my room. So I just wanted to train over an extended period. And I'm also using Rove Ultra in the PyBrain. And it's also in RoofFlow if you want to use it there. You just got to enable it. That's how I handle the background agents. Those always running agents where I don't want to spend money on Claude. It's using Rove LLM and Rove Ultra. So they run in the background. Again, they don't need to be smart for everything. They just need to be smart enough to do that one thing that they're intended to do. Background optimization of my security, stock trades for Stu, just needs to do those things. Train it to do those things and nothing else. Benchmark, optimize, and then use that. And if you can quantize it, if you're using my 0.5, you could potentially even fit it on the seed itself. Again, it doesn't need to be fast. It just needs to be good enough. Yeah.
So I like
I
the
gotta
idea
go.
of the Pi thing because the Pi brain. I mean, a lot of people are uploading their Obsidian brains left and right, and they're sharing it all over the place. I mean, I feel like um, it's kind of like the new Notion, where everyone's sharing their brain. But I feel like people would want to upload their brains onto Pi if they knew about it. Like they might have like how you have like your personal one, and then you have the collective brain, right? Like some
Yeah.
people might want to like the things that you were talking about, like the model weights, where like the whether it's like the LoRa fine tuning or it's like inferring whatever weights were coming from the model to get the task done that you wanted. Like I feel like people would want to
there's
either monetize them, like maybe like skills, like a skills marketplace where you could actually get paid for other people using your weights that work that can then get injected into like similar prompts to have them be successful.
Yeah, that's exactly what I'm doing. I've even got a system in here to where I put it here. There you can get Rove rewards. You can run this yourself and do exactly the same thing. It's the more you contribute, the more access you get, kind of thing.
Do you think you would be able to do an open router plug into it so you can earn credits in Rove and then like swap them for open router credits?
Anything's possible. Yeah, sure.
Because I feel like you can make a liquidity pool against like USDC or something, right? And
I
then
don't know. Sounds like my favorite SEC folks will show up again and give me the special treatment they love to give me.
well, I think if you sold like most of the I think if you sold most of the things for open router credits for the people to then buy, and it's just or you had like most of it be like a token buyback or something, where it's not really like a intended.
What I need to do is is now that I got a certain point, I could probably just create my own model, make it available.
Yeah.
I can now that we know how to decompile any Claude, I can just decompile the parts of Claude that are most useful for me, get the weights, create a model, and it would be indistinguishable when you're using Claude. That's actually what it should. I probably
Somebody
should talk too much.
ported,
So are you telling us
ported it
something
to Rust, didn't they?
beneath Rooflow that basically would allow us to use Rooflow without Claude?
Oh yeah, I built that last year. Yeah, that already exists. That's Agent Booster, but I'm talking I can probably get it even better. I'm just thinking out loud.
Well,
Sorry,
I mean,
sorry,
if we interact with a model and they give us back, something, and then we infer what weights we're likely use and then put that in our own, that's not like taking anything. That's just, you interact with a model that gives you intelligence. That intelligence is not yours.
Yeah, I like
Right?
the way you think. Yeah,
Yeah.
you do that and share it with me, and you find out if your account gets banned. They gave me a free account, so I feel a little bad that I would try to steal their weights using the free account they gave me.
Well,
Somebody did
stealing
a complete
logging into the
corpse.
server and pulling them off the server, like, but inferring what weights they might be using, it's not really that even. It would be different. Like if you if you overlapped the stuff from, like, if you just interacted with Opus for at like endless amounts, like millions of dollars worth of API calls, eventually kind of like got everybody, it still wouldn't, the weights still wouldn't like line up perfectly, right?
Yeah, exactly.
Yeah.
And that's where my micro LoRa would be perfect because they don't have to line up correctly. I can adjust those based on, sort of recalculation of the vector space. So I just need the intelligence, which I'm using like a transfer learning pattern and then transferring the most important parts of those learning to my model.
And then you could do machine learning on like the context injection, and then whatever's available in the brain, what does get injected to where like those weights may have not been needed, or what you can like create synthetic training sets off of that stuff too, right?
Yeah, exactly. That's exactly what you're doing.
You should definitely make it into a coin then.
Not me. No coins for me. I avoid that. I've got a history there, and I'm not going to touch that. All right, guys, I gotta go. I'll see you in a bit. Some of you guys are hopping on Stu's call here at 3. If you want to share any information, share it in the text area.
Yep.
Or invite me or whatever. Okay.
Yeah, you have the invite, right? I emailed you.
Probably.
Okay, just want to make sure so I don't lose you.
And should rotate that key.
All right. I'll talk to you later, guys.
Bye, all. Thank you.
Thank
Okay.
you.